Good evening, all. Is it okay? Shall we start? I, if you have any problem, please just make a WhatsApp call. Let us start. So, did the people had joined or not? Please say yes or no. It shows only count three. I don't know how many had joined yet. Okay, first download the question bank that I had posted in the group. First, let me fix the margin before that. Fine. I hope you all have downloaded the question bank. Just keep it with you. First, let us discuss about let us see the continuation of Z transformation, right? What we have seen yesterday, we saw the purpose of Z transformation and that is what we are doing in region of convergence. Properties of ROC, region of convergence, have been concluded perfectly, right? Now, what is our next task? We have to understand the properties of Z transformation, and nothing is there to understand new, right? We are not going to learn anything new in these properties, but we should understand, right? What we have to understand, let me demonstrate. Slightly we are going to look at these things slightly different because here we are considering z values, no? Okay, anyway, first one is what? The property number one is linearity. Take the property number one, properties of z transformation, right? So property number one is linearity, right? According to linearity, if I have a system, right? For an example, if I have an input signal, as x1 of n, its correspondent z transformation is going to be x1 of z. Similarly, let us define its ROC can be defined as, right? Its ROC, let's say some radius with some values that is not known, right? But some common value, it has some certain ROC. Similarly, I have one more signal. Let me show the difference. Let us call it as R1. I have one more signal x1 of n. Its ROC, its Z transformation can be defined as x2 of Z, right? And its correspondent region of convergence, let me define it as R2, some other values. Now, when we are clubbing these two people, according to linearity, you can club these two things together, x1 of n, x2 of n. Instead of passing them separately, you can also club them together and then you can pass it through the system such that its correspondent Z transformation is going to be x1 of Z plus x2 of Z and its correspondent region of convergence. Its region of convergence is going to be what? We all know when we have more than one pole, ஒரு சிஸ்டம்ல ஒரு போலுக்கு மேல போல்ஸ் வந்துச்சு அப்படினாலே which is your ROC common region, right? See, I have two system here. System number 1 has the ROC of R1, system number 2 has the ROC of R2. If I club them together, then resultant ROC is going to be the common region. Region of convergence should be common in the sense intersection. We are considering intersection R1 R2, right? At which area they are going to overlap each other, that is called region of convergence when we are clubbing these two signals together. Clear? Yes. So this is all about linearity. Let us discuss about the second property, that is called time shifting. Let us discuss about time shifting, right? That is one of the most important property. Let us try and understand time shifting, right? According to time shifting, if I have a signal x of n in time domain, if I have a signal x of n in time domain, then its correspondent z transformation is going to be x of z. First one, suppose in the time domain, if your signal is being shifted by n naught, right? I have a signal. That signal in the time domain itself, it has been shifted by an amount of n naught, such that its correspondent shifting is what? Inga enna shifting varum? Exponential raising. But exponential in the sense we are considering z naught, it will become z power minus n naught into correspondent transformation is going to be considered as x of z. Clear? For x of n, if its region of convergence ROC, its region of convergence ROC is going to be R, then shifting does not change the ROC. Once again you are going to get the same ROC only, right? So shifting property of the system does not change the value of ROC. So whichever the ROC, region of convergence, that had been different for the normal signal, right? After shifting, after providing the shifting, again you are coming up with the what? Same type of, that is the same value of region of convergence. Clear? Okay, let us proceed. So this is all about time shifting. Now let us discuss about scaling in z domain, right? So scaling usually we are not doing in time domain, but we can do scaling in z domain. Let me explain it. So for that, let me rub these things. So scaling in z domain. If I do scaling in z domain, let's see what happens. When I am doing scaling in z domain, for example, if I have a signal x of n, scaling in z domain, just write down scaling in z domain, x of n, its correspondent z transformation can be defined as x of z with its region of convergence ROC can be simply defined as R. Now when I am doing scaling in the sense, for example, if I have a signal here, right? If I have a signal that is called z, and that signal is being scaled by a factor of 1 by z naught, right? We are scaling the signal in z domain. If a signal is being scaled in z domain, then in its correspondent time domain you can observe there is a exponential rising, that is your signal would have been multiplied by, right? So x of n would have been multiplied by z naught whole power minus n. Just you can see the observation, right? So that is called scaling, that is called scaling factor. If it is denominator, then here we have plus, right? Okay, just keep like this. Let us proceed. Under its correspondent region of convergence ROC, whenever we are doing this scaling, if your signal is being scaled in z domain, then in time domain you can consider your function is going to be multiplied by the factor of z, such that its ROC also going to be multiplied by z, right? Its ROC also going to be multiplied by same factor z naught times of R. Just to consider the magnitude for this z naught. Clear? Yes. Let us see the next property, time reversal, right? So the next property that we are going to look at now is called time reversal. The next property is time reversal. Time reversal, that is very simple, right? Let me define. Time reversal, this is for x of n, its correspondent z transformation can be simply defined as x of z with the region of convergence is going to be simply R. Suppose if I have a signal, right? Time reversal in the sense your signal is being reversed in time domain, then in z domain what will happen? In z domain your function can be defined as z power minus 1, or this function can be rewritten as x of 1 upon z with its correspondent region of convergence ROC is also going to be reversed. See, notice these things, they are very important because you will be tested for some worthless one mark questions in your examination. Simply they will give a region of convergence of a given signal is what I mean, they will give you some value and then they will ask you, then find out the region of convergence of x of minus n. right? If you remember the property in one step, just by looking at the option itself, you can pick the answer. If you do remember the property, so remembering these properties is very important. That's why I am always recollecting the ROC with this, right? So don't forget, that is very important, right? Fine. So that is how we are doing. That is time reversal. Next, let us see differentiation, right? Differentiation in Z domain. If I do differentiation in Z domain, some properties that are very important, right? So let us see differentiation in Z domain, right? If I am doing differentiation in Z domain in the sense, see, for x of n, its correspondent transformation can be defined as x of z. If a signal is being defined, that is differentiated in the Z domain, differentiation in the sense, see there, I am doing differentiation for this function with respect to z, such that what happened, this function is should have been multiplied by minus, right? And here you are getting n into x of n. Same thing, nothing we are going to learn new. Whichever things that we saw in Laplace transformation, right? Same thing I am defining, but the thing is we are doing these things in what? In discrete domain, right? So that is the difference, right? Nothing is going to be new. So this is called what? Differentiation. Next here we are going to learn a new thing, right? That is called convolution. And differentiation also, there is no changes in the ROC. Don't be panic, you can just write. If ROC of x of n is R, for x of n, for x of z is R, then same ROC we are going to get here also. There is no changes in the region of convergence, right? So let us discuss about convolution. When I am talking about convolution, if I have a signal x1 of n and its correspondent transformation is going to be what? x1 of z. x1 of z. Similarly, if I have one more signal, x2 of n, then its correspondent convolution, that is we all know these things, right? Its correspondent z transformation is going to be x2 of z, such that when I am clubbing them together, suppose if these two signals are in convolution in time domain, if they are being in convolution in time domain, then its correspondent, right, z transformation in discrete domain, what will happen? If two signals are in in convolution in time domain, then in z domain they are going to be simply multiplied each other, right? So we can define them. It's simply going to be multiplied each other, x1 of z into x2 of z. Okay, that's all. So that is how we are getting convolution. Simply I am defining, right? I am not defining any ROC at all. Just to know the property, right? If I have two signals in convolution, what we can do? That is what I am defining, right? So let us see ROC about, we will see, right? When developing the equations and all. Okay, fine. So this is the convolution property. That things we learn already. Next we should learn about conjugation property. Right? Next we have to learn conjugation property. Let me demonstrate conjugation property. We have to learn something new in conjugation property. Should try to keep your attention. So while talking about the property of conjugation, what I am going to do, conjugation of the meaning I see, if I have a signal x of n, its corresponding Fourier transformation, z transformation can be simply defined as x of z. Suppose if I am taking conjugation for x of n, we all know what will happen. What will happen? In discrete domain, its transformation can be defined as x conjugate of answer mind, right? That is z conjugation. Exactly, that is true, right? So let us estimate something here. Something, what type of something I am going to estimate? For an example, if I have a function, right? See, if x of z, listen, take this one. If x of z, and remember one more thing, this conjugation does not change the property of ROC. Once again, you can keep, if this region of convergence ROC is going to be R, then we can define this region of convergence also going to be R only. Directly we can define these things, right? So conjugation does not going to change the property. But the thing is what? Let us see. If I have a signal x of n and its corresponding transformation is x of z, now let us define. If x of z has, very important property, right? If x of z has a pole or 0, right, at some point, right? If x of z has some pole or 0 value achieved, at some point, that point is can be simply defined as, can be defined in terms of poles and zeros. What shall I do? Okay, let me define such that you will get the clear idea, right? Right. So see, x of z as a pole, right, at a point p in the sense of some value, that's all. Or it may be have a 0 at a point z, right? See there, if x of z has a pole of 0 at p denotes pole or location. 0, z denotes 0 or location, right? Some either then the next thing is x conjugate of z, right? Then x conjugate of z, right, has, just you can, as a pole or 0, right, as a pole or 0 at P conjugate, right, and Z conjugate. Getting me? Similarly, just understand the properties. Are you getting me? I am taking some transfer function. In the transfer function, I have some pole zeros, and the pole zeros are going to be placed at some specific locations. Now, if I am taking conjugation for this function x of z, then what will happen? It's correspondent, right? If I am considering x conjugate of z here, it means what happened here? I have some poles at p conjugate and z conjugate, right? So, see, let me define it first. Wait a minute, you have to understand. See, x conjugate of n equal to x conjugate, for x conjugate of n, our transformation is going to be what? X conjugate of z conjugate, right? Now, the thing is, if I consider x conjugate of minus n here, then what I will have? See there, if I have x conjugate of minus n, if I have x conjugate of minus n, then we understood already these things. Then here you can consider this conjugate, here this conjugation will be demolished, right? So that is the property. So here I am considering x conjugate of minus n, then that minus that we are going to consider here will be demolished, right? We are not considering the things. Okay, let us go ahead, let us proceed. Now let me write few more things here. I have to conclude with some other things. Wait a minute, slowly make a notes. Nothing is there to understand, but something is there. See, we saw for x of n, its corresponding transformation is x of z, and its region of convergence is going to be R. Now, if I have x of minus n, then it indicates its corresponding transformation is going to be x of 1 by z. Clear? At the region of 1 by R. And I said this region of convergence is also going to be reversed. Now, in the same way, listen, if it is defined as, if x of z, right, once again, if x of z has a pole, if x of z has a pole or 0, if x of z has a pole or 0 at P or z, P denotes pole, z denotes z 0, then x of minus, that is x of 1 by z, then x of 1 by z, same thing, has a pole or 0 at 1 by P, here you are going to consider 1 by z, that's all. That is the next property that we are going to learn here, right? That is very important property, right? And so you have to remember these things, right, by solving the problems. So similarly, if I am considering conjugate here, if I consider 1 by z conjugate, then here also you are going to get 1 by p conjugate, 1 by z conjugate. Like x of z as a pole or 0 at p or z, then x of 1 by z conjugate will have a pole or 0 at 1 by p conjugate or 1 by z conjugate. These are the some of the properties that we are observing from the z transformation. Are you getting me? X of z அப்படிங்கிறது ஒரு transfer function. அதுல ஒரு poles and zero க்கு some values இருக்கு, அதை நம்ம observationல locate பண்ணியாச்சு. Then we are understanding from the analysis we understood if I have x of 1 by z, then its corresponding poles and zeros are going to be what? 1 by p, 1 by z. That is how we are defining these pole zero conjugation properties, right? Okay, fine. Okay, let us see. Let me rub these things. Next, so this is the conjugation property that we know. If x of n is real, right? So let us define. If x of n is real, property of conjugation once again. Let us start from here. If x of n is real, then we all know. If x of n is real, then x of n should be equal to what? X conjugate of n. Is there a mistake? No. If x of n is real, then this is the statement. That is true. Similarly, I can define. Then its z transformation. If x of n is equal to x conjugate of n, then its z transformation is going to be x of z should be equal to what? X conjugation of z conjugation. X conjugate of z conjugation. So what will be the conclusion? The conclusion is if these two people are equal, then these two people are also going to be equal. So it denotes if x of z, right, you can write this statement. If x of z has a pole or 0, right? Wait a minute, I will write it clearly. If x of z has a pole or 0 at point P and z, P or z, right? P denotes poles, is 0, z denotes zeros, right? Then what will happen? You can also consider the same point. You can also consider if x of z has a pole of 0 at point P1, that is P by z. At the same point, what will happen? X conjugate of z conjugate also have a pole under 0, pole or 0. Clear? Then at the same point, you can also consider then x conjugate of z conjugate also have, right? Also have a pole or 0 at the what? P comma z. Or we can also define what? It should be equal to P conjugate z conjugate. We can also define it in terms of P conjugate and Z conjugate. I hope these are clear to you all. If I take reciprocal, then what will happen? 1 by P conjugate, 1 by Z conjugate. If I take reciprocal here, then here this become what? 1 by P conjugate, 1 by Z conjugate. Clear? Yes. So this is when x of n is going to be real. Similarly, when x of n is going to be imaginary, then what will happen? You know, it will be multiplied by a factor of minus. That is, x of n should become equal to, while taking conjugate, you are getting minus here, right? Sign will change. That is called imaginary property, right? So anyway, next we have to understand the question is will be tested for few more. In the same way, you can observe all these things, right? But something I am defining that are very important. The rest of things are the already you have understood. You can just go with that one. If x of n is real and even, right? Next property, first we saw real and x of n is real and even. Then what happens? If x of n is real and even, then we have to understand the property is, if x of n is real, then x of n should be equal to what? X conjugate of n. Yes or no? Do you agree? Real property of x of n, x conjugate of n equal. Even x of n equal to what? X of minus n. Now just now we have been observed what is the observation we took for x of n, right? Its corresponding Fourier transformation can be defined as x of z transformation. For x conjugate of x, z, its corresponding z transformation can be defined as x conjugate of z conjugate. For x of minus n, its corresponding z transformation can be defined as 1 upon z. Now, did you notice if x of z has a pole or 0 at a point P or z, then what will happen? Then x conjugate of z also have a pole. At the same point, you can consider P conjugate and z conjugate. Then this one, right? It should be equal to what? It should be equal to what? This person also will have a pole at 1 by P and 1 by z. Clear? So these all things are going to be equal when these three people are going to be equal. Just to should try to understand, because you will be tested for some worthless one mark questions. These are the properties that we are observing from the z transformation or from the system. Clear? Yes. So these are the properties of our z transformation, right? So let me rub these things. With this, properties of the z transformation is completely over, right? That's all. There are no more things to understand. Now the next target is we have to solve various problems in order to understand the z transformation. You might have see what is we have been discussed about Fourier transformation in continuous domain, in discrete domain, Laplace transformation. Now we have been concluded z transformation, and we have been discussed about Fourier series, Fourier transformation. Fourier series. So these are two things, right? What I can say, trigonometric Fourier series and exponential Fourier series. What we have understood from all those things? Just we are analyzing the properties of some system. That system is what? That system has sometimes that system might be stable, or sometimes your system might be unstable, right? Sometimes your system might be periodic or aperiodic, some randomized signals also will exist, right? So all these things, right? In discrete domain, we are analyzing discrete type of systematic signals. In continuous domain, that is in Laplace continuous domain, what we are doing? We are analyzing all type of stable, unstable, periodic and aperiodic, but all are what? Continuous time signals. Clear? Okay. That's all. There are no more things to understand, and it's very easy. I hope you all have understand. Just the properties also remain same. I am not going to, that is, I did not taught any new things, right? Okay, let us start. Just to open up the question back, let me solve few problems for a better understanding, right? Wait a minute, I have to open it. I hope you all also, that is, you all having the question bank with you. Just to take it once. First try it, right? Slowly try it, because questions are very easy. First, what is the question? Question number 1. The z transformation of a time function, and it is simply going from k is equal to 0 to infinity, is del of n minus k. Right? They are given some function, and that function is what? It's simply going from k is equal to 0 to infinity, and its value is what? Del of n minus k. Did you notice what is this? And the function and the arc equal. So let us see. First, this is some function and this running from n equal to 0 to infinity. Listen. Question number 1. We have a function. The function is running from n equal to 0 to infinity. Right? Wait a minute. I have to notice these things. That is k. Right? And del of n minus k. Just by looking at the question itself, I could not understand anything. But let us slowly understand. Let us plot the waveform, because I don't know the answer. But I would like to indicate to you are requested to draw the discrete time Fourier transformation. That is z transformation. Right? But if we z transformation apply what I have to do? let us see. We have to analyze the property of the signal. Let me draw the. Let us plot the waveform. Its waveform is going to be, see there. If I replace k equal to 0, first substitute k equal to 0, then at k equal to 0, we are getting del of n. That del of n value is going to be 1, unit impulse, we all know, right? Similarly, let me replace k equal to 1. K equal to 0 to infinity, no? K equal to 1 putting up, del of n minus 1. It means the same sample, but it will exist at what? At n equal to 1, right? This sample will going to exist at n equal to 1. Similarly, if I replace k equal to 2, then what will happen? Same sample with the same height will going to exist at 2. Similarly, if I replace n equal to 3, sorry, k equal to 3, then the sample will exist at only 3. If I replace n equal to 4, then k equal to 4, then the sample will exist at k equal to 4. Like that, if you notice, this is called impulse train. Yes, I understood. That is called impulse train. Now, what type of signal it is? Is it impulse train? Yes, it is impulse train, that is correct. But let me draw the one more person here. I would like to draw the waveform of step function u of n. Can you draw the discrete time signal? In continuous domain, your step function can be defined like this. Whereas in the discrete domain, your signal can be defined like this, right? Because we are discretizing. At n equal to 0, we are considering the signal, and then at n equal to 1, we are considering the signal. At n equal to 2, we are considering the height of the signal. At n equal to 3, we are considering the height of the signal. At n equal to 4, we are considering the height of the signal. Like that, at n equal to 5, at n equal to 6, at n equal to 7, and so on. The signal is keep on going, right? So the difference is in continuous time domain, your signal is continuous, and we are considering all values. Whereas when I am looking for a discrete time domain, this is how your questions, that is your signal is being looked like. Now, what is the difference between this? Nothing, right? So, what is the conclusion? This whole function should be equal to step function. You will understand, right? By practice, it will become easy, right? Just you have to investigate, right? I am just doing the investigation. So, what I have understood, u of n can also be written in this way. U of n can also be written in this way. That is called impulse train. This train is called impulse train. So, impulse train should be simply equal to, it will be simply defined as what unit step function, right? Just the questions that we are being taken, to collect some information from the question, that questions have been given to you. So, we will collect some data, we are going to collect from the question itself. So, this is called impulse train, and it can also be represented as u of n. Let us see. So, what is the conclusion? This whole function can be replaced by u of n. Now, the question is, for u of n, what is the Z transformation? Do you know? Yes, we have seen it already. Anyway, let me do it. In order to know the Z transformation for the given function, we know the formula. The formula is, if I have a function x of n, then if you want to transform the signal from n domain to z domain, then the formula is what? Let us see. If you want to know x of z for any function, just run from n equal to minus infinity to plus infinity with the value of x of n into z power minus n. Now, since the value of x of n is going to be u of n, when I am replacing x of n by u of n, then the value of u of n will going to be 1 from 0 to infinity. In the rest of zone, that will be 0. Can I write like this? Yes. This function can be written as n equal to 0 to infinity into z power minus 1 whole power n. Now, yesterday what we saw, we have seen the series expansion formula, right? So, what we saw, let me write them all, right, once again for better understanding. What we saw, from the observation of series expansion, if any signal is running from 0 to infinity with the value of c power n, it can be written as, in the numerator we are considering first term, whereas in the denominator we are considering the effect of 1 minus common factor, that means we have been observed. So, in the same way, which is the first term here, if I replace n by 0, z power minus 1 whole power 0 will become 1 upon 1 minus common factor is going to be z inverse. So, I can define here, this function can be defined as, you can also write this one as 1 upon 1 by z. 1 upon 1 minus 1 by z. If I take reciprocal and what I can say, denominator be numerator after taking LCM, so this function can be written as z upon z minus 1. Whereas, what will be its region of convergence? Region of convergence, you can define it from here. So, mod of z inverse should be what? It has to be less than 1, or I can say 1 by z should be less than 1, or I can say the value of z greater than 1, such that its region of convergence should be greater than 1. So, the correct answer for the impulse train, its corresponding Fourier transformation will be fixed to what? Z upon Z minus 1 with its corresponding region of convergence. Mod Z should be greater than 1, or we can say ROC should be greater than 1. Clear? So that is the correct answer for the given question. Let us check the options. Option A or option B. Now the next question is what? The Z transformation of the function f of nt is equal to a power nt is dash. Just to do it by yourself, don't wait for me. Anyway, let me do it. Right? So let me rub this one. Let us rub this function and then let us bring the answer for the next function. Right? So let me rub this one. Let us try to bring the answer for the next function. Right? Yes. Yes. What is the next question? F of nt a equal to a power n into t. Yes. A power n into t only, no? Yes, that is a power n into t. Now the question is what? You are requested to find out the Z transformation of f of n into t. Wait a minute, I will check. F of n into t, and this function can be written as a power n into t. What will be its Z transformation? Its Z transformation is going to be, right? Once again, if you want to know the answer for this function, how the Z transformation can be written as x of z is equal to the generalized formula summation n equal to minus infinity to plus infinity. Function can be written as x of n into z power minus 1. But now let us reduce the function further. If you want to reduce the function, I will have to run from n equal to minus infinity to plus infinity. Right? With this, wait a minute, I have to notice the function carefully. Anyway, so that is, it was written as a power n into t only, right? So you can plus a power n into t, right, into what? Z power minus n. See, can I consider this sample from n equal to minus infinity to plus infinity? No. So we can consider only what? So this function, this sample may be continuous from what? 0 to infinity, or it may be running from minus infinity to plus infinity. I think they forget to consider one more function here. Let me multiply by a sample of u of n into t. Right? So just to multiply by u of n into t or u of t. Right? Because in discrete domain, this n into t is nothing but u of n only. Don't think too much. Clear? So let me multiply by u of n such that this function is going to be what? It can be written as n equal to 0 to infinity a power n into t dot z power minus n, such that this sample can be further reduced to be summation n equal to 0 to infinity. This function can be written as a power t dot z power minus n whole power n, such that your finalized answer for this function will become what? We have to consider first term in the numerator, that is 1 divided by 1 minus common factor can be written as a power t dot z power minus 1. Further, first let me define the ROC. ROC of this function become mod of a power t dot z power minus 1 should be less than 1, or we can say a power t upon z power 1 should be less than 1, or we can say region of convergence z should be greater than a power t. So let us write the answer directly. So z should be greater than a power t. That is the region of convergence for the given function, as well as we can also define the answer. If I reduce this function, it can be further reduced to be 1 upon 1 minus a power t. In the denominator we are going to consider z power 1. If I take LCM and then take reciprocal, not reciprocal, denominator will be positive to numerator, such that this function can be written as z upon z minus a power t dot, or comma, we can write the region of convergence z is going to be greater than a power t. So that is the correct answer for the given function. Let us see whether we have the option or not. Z upon z minus a power t. So the correct answer is option A. Okay, let us see the next question. Take the next one. What it was given? The z transform of the signal is given by x of z, s c of z, right? I know I did not given the formula for find value theorem. I know, right? Because I have seen this question already. In order to solve this question directly here, I did not consider the effect of z inverse. Let me write it, right? Don't worry. So let me rub these things. Now the question is what? Final value of the function is what? In the initial value, there is no changes. Whichever the formula that we saw in our previous case, we can use it, right? But in the final value function, there will be some changes. Here we are going to consider the standard final value formula is. Let me write it. First, final value theorem, and then let us see the answer for this function. Yes. So final value theorem for the function can be defined as. Let us define final value theorem. First of all, you all have to notice one thing. What you all have to notice, final value theorem is only applicable for whom? Question mark. Final value theorem is only applicable for whom? The answer is stable system, right? It is only applicable for stable system, or I can say Bibo system, or we can say Bibo system, or we can say absolutely summable system, right? Sorry guys, or we can say absolutely summable system. If your system values are absolutely summable in discrete domain, the condition is what? Absolutely summable, right? So if any system satisfies this condition, then we can apply region of convergence, that is we can apply finality theorem for that function, right? So okay, let us write the finality theorem formula. So the formula is final value in the sense, once again, n is approaching infinity such that I'm supposed to write, right? I'm requesting you all to find out the value of x of infinity, because we are trying to find out the final value such that this function can be defined as, for discrete domain, the formula is limit, right? You see, here my n is approaching infinity, whereas my z is supposed to approach 1. We are considering unity circle, right? Because we are considering what? Stable system. In stable system itself, we will know this statement. Stable system in the sense, we have to consider unity circle. If the unity circle lies under region of convergence, then only you can proceed further. So always we are trying to estimate the value or stability of the system at z equal to 1 only, right? So with this, its z transformation can be defined as 1 minus z power minus 1 into x of z, or this function can also be defined. It can also be written in the alternative way. The alternative way is limit z is approaching 1 only, but this function can also be defined as z minus 1 into x of z. All right. Clear? So that is how we are trying to find out the value of z transformation. I hope these things are very clear. Now let us take the given function and then we will apply this formula in order to find out the answer for the given question. Let me run this one. In our case, what it was given, they said, right? They said what they said. Z transformation of the signal is given by C of z is equal to z power minus 1 dot 1 minus z power minus 4 upon 4 into 1 minus z power minus 1 whole square. For this only, they are requesting us to find out the final value. Do you remember? Whenever we are looking for final value, right? First, before applying the final value, you should try to cancel. Listen, wait. First, let me apply the final value formula. Anyway, we are requested to find out the value of c of infinity. For that, the formula is what? Limit z is going to approach 1. Guys, listen. In the கொடுத்திருக்க terms வந்து the power of minus 1 negative ல இருக்குது அப்படினா, right? If the power value are in negative, then use the second formula. That's the first formula. 1 power z minus 1 into x of z. Here we are considering c of z. Use this formula. Right? Suppose if you have your power coefficients are positive, then use the second formula. Second formula is what? Z minus 1 into x of z. So this is for positive power coefficients and this is for negative power coefficients. Clear? So it's clearly denotes that the given function is what? It has negative power coefficients. Shall we test it? Yes. Let us test this function now. Let me substitute the values. Oh my god. Sorry. Limit z is approaching 1 and this function values are 1 upon z power minus 1 into c of z can be written as z power minus 1, just to substitute this value here, into 1 minus z power minus 4, right? In the denominator, once again this function can be further written as 4 times of 1 minus z power minus 1 whole power 2. One term is getting cancelled, right? One term is getting cancelled, and some of you might be thinking this answer is infinity, but that is wrong. Let me prove it. Wait, don't be panic. Let me prove it, because I often faced this type of questions in the examinations. When I have been faced, right? They will test you with some basic knowledge. Let us see what happens in this function. Definitely there will be some term is getting cancelled. How? Let's see. Check பண்ணிடலாமா? இப்போ பாருங்க, இப்போ வந்தோடனே நமக்கு என்ன ஆகுதுன்னா, you might be thinking, sir, இதுக்கு மேல இந்த ஃபங்க்ஷனை ரெடியூஸ் பண்ண முடியாது சார். Let's stop with this and let us replace z by 1, sir, such that it is become what? 1 minus 1 will become 0, 1 minus 1 will become 0, 0 by 0 will become indeterminate format. Can you proceed further? You cannot do anything, right? So what shall I do? Just focus. They won't give indeterminate format. they will testify, they will test you with some determinant format only, but you will have a stuck at this point itself. Some of you might be directly keep the answer as 0, some of you might left the question because you won't get the clear idea, but you have to carefully observe. எப்பயுமே என்ன வரும் அப்படின்னா, நான் இப்போ கவனிங்க, ஃபைனல் வேல்யூ தியரம் அப்ளை பண்ணும்போது we are considering a coefficient is called 1 minus z power minus 1. ஸோ இதே மாதிரி ஒரு டேர்ம் டினாமினேட்டரில் வந்திருக்கு அப்படின்னா அந்த டேர்ம் கண்டிப்பாக யாராச்சும் ஒரு டேர்ம் நியூமரேட்டரில் இருக்க டேர்மால கேன்சல் ஆகிற மாதிரி தான் கொஸ்டின்ஸ் கொடுத்துருப்பாங்க. If it is not being cancelled, then your value is being approaching to what? Infinity. But you have to check carefully, right? Can you cancel this 1 minus? Can you cancel this 1 minus z power minus 1 with some people? ஏதாச்சும் ஒன்று பண்ணி இதை கேன்சல் பண்ண முடியுமான்னு யோசிச்சு பாருங்க. Do you have any idea? I don't know. You might be wondering, right? So you might be thinking and you may not get the idea, right? I am also thinking, but I am getting some idea. Check let's see. I am getting some friction with this value. In the 1 minus z power minus 4 பார்க்கும்போது எனக்கு ஒரு மைண்ட் ஒரு ஃபார்முலா வந்துட்டே இருக்கு. அது என்னன்னா a square minus b square. Because 1 square பண்ணா 1 தான் வரும். See, நான் இத கம்பேர் பண்ணும்போது I am thinking like இதுல 1 square எழுதா minus z power minus 2 whole square எழுதலாம். Is there a mistake? That is correct. If in the மாதிரி ஒரு function, see there, a square minus b square நம்ம எப்படி எழுதுவோம்? It can be written as a minus b into a plus b. Exactly. In that way, what shall I do? In the function நம்ம further reduce பண்ணிக்கலாமா? எப்படி reduce பண்ணுவோம்? It can be written as 1 minus z power minus 2, that is a minus b into 1 plus z power minus 2, that is a plus b. Sir, okay, reduce பண்ணிட்டீங்க. But I don't get any idea. Again I had a friction. திரும்பவும் எனக்கு இது அப்படியே சப்ஸ்டிட்யூட் பண்ணா கேன்சல் ஆகல. But again I am thinking, இதுக்கு இன்டீரியர்ல செக் பண்ணி பார்க்கும்போது again I am getting a friction. என்ன friction? See there. Once again, according to the formula, a square minus b square from this function. Let me take this function alone. Shall I write this function like this? 1 square minus z power minus 1 whole square. Just think about it, right? They will let you all to work. உங்களோட brain work பண்ண வைக்கிறது தான் அவங்களோட வேலை. Right? So கண்டிப்பா question அப்படி தான் frame பண்ணுவாங்க. Is there any mistake? No, nothing is there. Just a very simple fundamental basic formula that we learn in our 9th standard mathematics, right? With this they are framing this 2 mark question. Worthless question, but by practice should be required, right? Let's see. So 1 square minus z power minus 1 whole power 2. How do I reduce this function? This function can be bundled as a square a square minus b square can be written as a minus b into a plus b. Yes or no? Yes. Finally, happily we got the answer. The answer is what? This 1 minus z power minus 4 can be replaced by 1 minus z power minus 2 into 1 plus z power minus 2. Again this 1 power z power minus 2 can be replaced like this. So finally what we are getting? Let me write the answer. So let us rub this question. Let us try to bring the answer for this question. What we limit z is approaching 1, right? And this function can be written as z power minus 1 into this 1 minus z power minus 4 would be finally replaced by, we can write like this, 1 minus z power minus 1 into 1 plus z power minus 1 into 1 plus z power minus 2. Right? This 1 plus z power minus 2 I am considering directly. This 1 minus z power minus 2 can be broken like this in order to cancel the denominator effect. So that is going to be 1 power minus, that is 1 minus z power minus 1, such that these two values are going to be cancelled each other. Finally, let us replace z by 1 happily. If the z is being replaced by 1, then 1 power minus 1 will be 1 only. Again, 1 plus 1 power minus 1 will be 2. Because 1 power minus 1 is always 1, right? Once again, 1 plus 1 power minus 2 also 1 only, right? So we are getting 2, right? Denominator we have 4. So what is the answer? We are getting 1, right? So let us test. Option 1 irukka? Option 1 irukka? Yes, we have option C. So the final answer for the given function is 1. That is the correct answer. Okay, just to make a note of it. Yes, I hope things are clear. Okay, just make a note. Next, the region of convergence of the z transform of a unit step function. We know the answer. What is the answer? Right now, just take one that is mod of z greater than 1. So the correct answer is mod of z greater than 1. That is the region of convergence. Next, if the impulse response of the discrete time system h of n is defined as minus 5 power n into u of minus n minus 1, okay, the system function is h of z is equal to what, right? Let us test it, right? Actually what it was given it is an anti-causal signal. Do you agree? Yes. Now we can easily find out the region of convergence as well as z transformation. Let me write, okay, question is minus 5 power n into u of minus n minus 1. Let us see the answer. You can write the answer. Z transformations are always very easy, right? Let's see. What is the answer? Some of you might write the answer because question is very easy. Minus 5 power n into u of minus n minus 1. First tell me, is it anti-causal signal or not? Yes. What about its region of convergence? Wait a minute, its region of, yes, 5 power 1 only. I thought it is 5 power minus n. Yes, that is correct. Okay, let us proceed. First, we all know it can be rewritten as, okay, for your understanding, let me redefine these things, how to bring the answer for this function. Suppose if you are not knowing these things, I know region of convergence we never defined, right? So let me, for your understanding, let me do it once again. If you want to know the x of z for this function, actual formula is what? Summation. We are running from n equal to minus infinity to plus infinity, and the thing is what? The formula is x of n into z power minus n. That is the general formula. Now here I am writing the function is going to be n equal to minus infinity to plus infinity, whereas x of n can be replaced by, it is going to be replaced by minus, let me keep minus outside, 5 power n into u of minus n minus 1 into z power minus n. In the next step, we found one thing. What we have found? See, since my function u of minus n minus 1 will going to travel from only from n equal to minus infinity to minus 1. That things we understood already. So with the 5 power n into z power minus n. Now, when we are interchanging the limits, minus summation, you can also interchange, right? Your limit can be written as minus 1 to minus infinity, right? We can write the function as 5 power n into z power minus n. In the next step, if I don't want to consider this negative value for this limit. For that, if you want to consider positive value, you can consider. Instead of running from minus 1 to minus 1 to minus infinity, we can also travel from plus 1 to plus infinity by changing the sign. See what I am doing here, I am just multiplying these things by minus 1. Such that this minus 1 will become plus 1, minus infinity will become plus infinity, n is being replaced. Sign of n is being changed here. So wherever you have the n sign is being replaced. N will become minus n will become plus n. Now, in the next step, it is further written as n equal to 1 to infinity. This function can be reduced to be, shall I write like this? 5 power minus 1 dot z power 1 whole power n. Can we write like this? Yes. Now, according to the series expansion formula, so this function can be finally written as minus of what I have to consider. If any function is traveling from 1 to infinite, right? So if they are traveling up to infinity, then the function can be written as, you have to consider first term in the numerator. First term is what? 5 power minus 1 into z power 1. So first term is 5 power minus 1 dot z power 1. In the denominator we have to consider 1 minus common factor. This is the common factor. So 5 power minus 1 dot z power 1 is the common factor. As well, first term in the sense I have to replace n by 1. So we are getting 5 power minus 1 into z power 1. Now in the next step, do one thing. In the numerator I have, let me consider this minus into this. Minus 5 power 1 into z power 1. Denominator, take minus 5 power 1 into z power 1 outside, such that this become minus 5 power minus 1 into z power 1. In the bracket this become 1 upon 5 power minus 1 dot z power 1 minus we took already outside, so it will become minus. It will become minus. See there? In the minus thing, plus so that it will become minus. And second thing is here, the denominator. Correct? Anyway, these two people are going to be cancelled each other. So the answer is going to be 1 upon. Now you can bring these two people to the numerator. So it has become minus 5 power plus 1 dot z power minus 1 plus 1. Now this function can be rewritten as 1 upon 1 minus 5 dot z power minus 1. Now what about the region of convergence? Anyway, when I am applying the formula on this function, right, the denominator term, this value should be restricted, right? 5 power minus 1 dot z should be less than 1. right? Because in the denominator your value should be restricted. You cannot keep unstable values at all, right? Or divergent values. So from this I can define what? Z by 5 should be less than 1, or I can say Z should be less than 5. So what is the conclusion? Its region of convergence ROC should be less than 5. We all know it is less than 5 only. Why? Since given it is what? Anti-causal signal. Right now, from here we can directly define. We all know how to define. Now we are படிச்சாச்சு கரெக்ட்டா. இதோட ஆன்சர் என்ன வருது நம்ம எல்லாருக்கும் தெரியும். That is 1 upon 1 minus இங்க என்ன வேல்யூ இருக்கு அது அப்படியே இங்க வந்துரும். 5 dot z power minus 1 and its ROC what? We are defining, right? We have been habituated. ROC should be anti-causal means less than இங்க வேல்யூ என்ன இருக்கு 5, so that is less than 5. So that is what we got finally. So that things we have been proved already. Anyway, I would like to create some friction with you all. So now tell me whether this system is stable or not. Okay, now we got the answer for the function. It can be written as either you can write like this, and this function I can also be see. Actually, the option they have not written like this. Either you can write எழுதலாம், இது நீங்க ரெடியூஸ் பண்ணீங்கன்னா z இன்வெர்ஸ் நம்ம டினாமினேட்டர் பாஸ் பண்ணலாமா? 5 by z, sorry, 5 by z. Then z cross product பண்ணீங்கன்னா it will become z minus 5 divided by z வரும், such that this answer will become, right? So this function can be written as z upon z minus 5. So that is the z transformation for the given signal. Now whether the system is stable or not, if you want to know the stability, then you have to draw the region of convergence and you have to test whether the unit circle lies under the ROC or not in order to testify, right? Let us see. Let me draw the region of convergence. Now when I am drawing the region of convergence for the given signal, ROC is less than 5. Just to take a compass from the origin, make a radius with 5 just to make a circle, right? So this is the radius is 5 and we are making this circle here. Such that what will happen? Its radius is 5. Now where is the unit circle? We all know it is 5. Unit circle somewhere lies nearer to the origin. This is, right? Its radius is what? 1. That is the unit circle. Now given it is what? ROC should be less than 5. So less than 5 in the sense this is going to be the region of convergence, right? So in the region of convergence, see there, what is the conclusion? ROC includes unit circle. ROC includes unit circle such that the given system is what? Stable system, right? If ROC lies under ROC, if unity circle lies under ROC, then the system is what? Stable. That is the statement. So what is the finalized answer? For the given function, its correspondent z transformation is going to be z upon z minus 5, with the given system is highly stable system. That's all. That is the correct answer for your given function. Option irukka? Option B போல, right? Option B தான். அடுத்த क्वेश्चन எடுத்துக்கலாமா? Please wait a minute. Proceed. The sequence x of n with the z transformation x of z equal to z power 4 plus z power 2 plus z power 2 minus 2z plus 2 minus 3 power 3 into z power minus 4 is applied as an input to a linear time invariant system with the impulse response h of n equal to 2 into del of n minus 3, where del of n equal to 1 at n equal to 0, yes of course, otherwise it is 0, fine. The output at n equal to 4 is dash. Okay, the question is at n equal to 4 what is the output of the function? Let us see actually what it was given. We are passing a signal through the linear time invariant system. Its impulse response of the system is already given, right? If you noticed, actually they are given, right? Or LTI system கொடுத்திருக்காங்க. Through that LTI system we are passing the signal. Anyway, we all know one thing. What we all know, according to the property of convolution, just now I had defined, right? Let me recapture the things. Right? Listen. For an LTI system, right? So whenever we are looking for LTI system, the property is LTI system in the sense that system had been tested by whom? Impulse. Right? We have seen. That's why I made a separate lecture on LTI system. I am repeating once again. LTI system denotes first step is after designing linear time invariant system in the laboratory itself. Your system is what? Your system is undergoing to test. That test is called impulse test. After completing the impulse test, your system is, that is, you can purchase the system and you can use it for our domestic or whichever the application that is based on, right? So the conclusion is what? LTI system is impulse response only, but they say the answer for the LTI system. But one thing all want to understand: in case of LTI system, input signal is called x of n, and your system is simply defined as h of n. Whenever I am passing a signal x of n through the h of n, the output of the system y of n can be concluded as x of n is going to be in convolution with the h of n. Do you agree? Yes. That is the basic fundamental property of an LTI system. Yes, exactly, that is true. If your system and the signal are in convolution, right, they are being converted in time domain, then what about in z domain? Its correspondent z transformation can be defined as x of z. Its correspondent, right, z transformation can be defined as h of z. Then its correspondent output is going to be defined as y of z, and that function is known as the product of x of z and the system h of z. Yes, happily. Now this is going to be the answer for our function, and then you will see at n equal to 4 what we are going to get. Right now we have to, our target is this one. Now what was given in the question? Let me take the question once. See, now in the question, x of z is given as z power 4 plus z power 2 minus twice of z plus 2 minus 3 times of z power minus 4. Now just we are passing this signal through this system. See, impulse response, what it was given, they said h of n had been replaced by twice of del of n minus 3, right? I think that is twice of del of n minus 3. Now let us use the shifting property. We all know for del of n, its correspondent z transformation is going to be 1. We saw already. Similarly, if I am doing shifting, if it can be written like this, del of n minus n naught, then it can be written as z power minus n naught into 1. Because for del of n, its transformation will be 1. If it is shifted by minus n naught, then here you can see the exponential shifting, that is z power minus n naught. Now, after completing these things, right, after completing these things, what is your next target? So del of n minus n naught can be written as z power minus n naught into 1. Of course, we are very happy. Now this n naught can be considered. Here we are considering 3. So here also we are going to consider 3. And since this system is being scaled by a factor of 2, then here also you have a scaling factor of 2. So twice of z power minus 3. So its impulse response, right? So its impulse response in the black they are going to consider. Right, so its transformation for twice of del of n minus 3 we can consider 2 into z power minus 3, such that output of the function can be written as it is the product of input of the system. Let us write the answer. Do it by yourself. Let me. Shall we do it? Yes. Anyway, first thing, 2 into z power minus 3 into z power 4 will become 2 into z power 1. Do you agree? Plus 4 minus 3 will become plus 1. Then 2 into z power minus 3 plus into z power 2 will become, once again, that is plus 2 into z power minus 1. Why? Minus 3 plus 2 will become minus 1. Next, minus 2 into z. 2 into 2 will become 4. Z power 1. Here we have z power 1. Here we have minus 3. Minus 3 plus 1 will become minus 2. Such that it can be written as minus 4 z power minus 2. Next, 2 into 2 will become 4. Such that it is become 4 times of z power plus 3. Next, minus 4 minus 3 will become minus 7. Minus 3 into 2 will become minus 6. It is become minus 6 z power minus 4 minus 7. Clear? So this is the value that we are getting in the resultant, right? Okay, fine. Anyway, we are in z domain. I would like to transform. I would like to get the inverse z value for this function, right? Inverse z in the sense, when we are taking inverse z transformation for this function, that is very easy. Inverse z transformation, whichever the things, நம்ம டைரக்டா வந்து டைம் டொமைன்ல இருந்து டிஸ்கிரீட் டொமைனுக்கு ட்ரான்ஸ்ஃபார்ம் பண்றோம் இல்ல, அப்படி நீங்க திரும்ப டைம் டொமைனுக்கு எடுத்தீங்கன்னா we are getting standard signals, right? So listen, what is the inverse z transformation of z power 1? See there. Here, let me take. Instead of having 2, suppose I have 1 with z power. Instead of having minus 3, suppose if I have plus 1, then what will be the answer getting back? Inga 1 irukudha, inga 1. So 1 into del of n. Here I have plus 1. See there, if I have minus 3, then here also you have minus 3. If you have plus 1, then here also you have plus 1. So what is the answer here? So it can be rewritten as del of n plus 1. Correct. Plus 2 into this function is going to be del of n minus 1 minus 4 into this function can be written as del of n minus 2, right? Plus this function 4 into this can be written as del of n plus 3. Now this function can be written as minus 6 into z power, sorry guys, this is can be written as del of n minus 7. Is it good? Yes, these things are good, right? Now for your best understanding, let me plot it in the graph. Anyway, from here itself we will get the answer, but for your understanding, let me keep these values in the graph. Can you please draw the graph for me? Because I have to let you all to get the very clear idea. For that I am just doing these things. In practice, you might do these things in your brain itself, right? I know that things, it will happen only by practice, right? It's only depending on your practice only. Let us push these values into the graph. So graphically I can pick up them, I can fix them at various positions. Let us fix. So this is minus n, yes, that is going to be plus n, we are in time domain only. Let us fix the value of y of n. See, twice into del of, 2 times of del of n plus 1. Del of n plus 1 in the sense n equal to minus 1. At n equal to minus 1, its value is what? Its height is 2. Its height is 2. Similarly, at n minus 1 in the sense, at n equal to plus 1. At n equal to plus 1, its height is what? Its height is 2. Its height is 2. Similarly, at n equal to minus 2, del of n minus 2 in the sense n equal to plus 2. But what about the magnitude? Minus 4. So, at n equal to plus 2, corresponding magnitude is going to be, let me write this one, corresponding magnitude is going to be minus 4. Now, at n equal to n plus 3 in the sense n equal to minus 3. Where is n equal to minus 3? That is n equal to minus 3. At n equal to minus 3, we have impulse value as 4, right? Height of the impulse is going to be 4. Next, at n equal to 7, we have minus 6. At n equal to 7, right? So let me run this portion. N equal to 7 is somewhere here, right? N minus 7 in the sense n equal to 7, and its impulse height is minus 6, right? So that is the finalized answer for the given function y of n. Yes, successfully we have drawn the graph value also. Now let us estimate. Question the function is, this is the output. Now the question is, at n equal to 4, what is the answer? Can you please tell me the answer? At n equal to 4, where we have, see there, at n equal to 1, I have some value. At n equal to 2, I feel I have some value. Where is n equal to 3? This is n equal to 4, we have. N equal to 4, I have some value. What do you have? No. So what is the answer? At n equal to 4, the answer is y of n should be equal to 0, because we have nothing. That's all. That is the answer. Similarly, you might be tested. At n equal to 0, we have 0. At n equal to 5, 0. At n equal to 6, we have 0. At n equal to 7, we have minus 6. At n equal to 2, I have minus 4. At n equal to minus 1, we have 2. At n equal to minus 2, we have 0. At n equal to minus 3, we have 4. So that is how we are being tested. Anyway, the correct answer for our question is 0. That's all. Next question. What is the question? The Z transform, let us see. The Z transform of a system is h of z equal to z upon z minus 0.2. If the region of convergence of mod z is less than 0.2, then the impulse response of the system is, right? Let us see. The Z transformation of a system h of z equal to, okay, it is given. What is impulse response in the sense? We know, right? This is h of z. h of z பொறுத்த வரைக்கும் impulse signal நீங்க பாஸ் பண்ணீங்க அப்படினா, see, let me demonstrate once again. Anyway, we have seen it, we have to refresh, right? Let me do it for understanding. Yes, let's see what is the answer for this question. Impulse response, once again we have to understand, that's very important, right? What do you mean by impulse response? Impulse response in the sense, impulse is the input, and we have an LTI system, that is h of n. So your system is being tested by impulse such that output of the system can be written as y of n is going to be, since it is LTI system. So in case of linear time invariant system, always your input signal will be overlapped with the system. That overlapping portion will be represented in terms of convolution. That things we all know, right? So it can be written as del of n. So this function can be written as del of n into, that is, it is going to be in convolution with the h of n. So we can also, in time domain, this can also be represented as in terms of summation. we are going to travel, right? So n is going to be travel from, that is we are simply traveling from n equal to minus infinity to up to some value, some dummy variable. Let me fix the dummy variable is p, right? So n equal to p, such that your function is can be defined as del of p dot h of n minus p. Do you remember in time domain how we are doing this? If two signals are in convolution time domain, let me define for understanding. So if I have a signal x of t and it was being in convolution with h of t, so this function can be defined as in time domain from minus infinity to t, that is tau is equal to t. We can define like this: tau is equal to t. Actually we are running like this: tau is equal to t, and your function can be written as x of tau into h of t minus tau into d tau. Same way I am approaching these things here. Actually here we are running from n equal to, see here your w variable is tau. Here let us see, let me write like this for understanding. See here my w variable tau is running from minus infinity to t. So after completing the integration with respect to tau, tau is being replaced by t. Your derivation will give you, in the sudden you are getting time domain values. Similarly we are doing the summation with respect to p. So p is equal to minus infinity to, let me write n. அப்ப இங்க function எப்படி வரும்? del of, here dummy variable is tau, here dummy variable is p. So similarly here n minus p, h of n minus p. That is in summation because we are in discrete domain. So that is how we are representing the signal in discrete domain. Anyway, what will be the conclusion here? I said one thing. The thing is, let us transform the signal. Instead of keeping them in the time domain, I would like to transform this into discrete domain. In discrete domain, del of n, its Z transformation is going to be 1. Whereas let us pass through the Z transformation of h of n can be done as h of z. Now what will be the output? Output is y of n. Its Z transformation can be done as y of z should be equal to 1 in the system. So that is going to be what? H of z. So why I am defining these things? If anywhere if you are looking, right, ஏதாச்சும் ஒரு இடத்துல அந்த impulse response of the system அப்படினு சொல்லிருக்காங்க அப்படினா output of the system ஓட வேல்யூ ஈக்குவல் தான். அந்த system ஓட output system ஓட வேல்யூ ஈக்குவல் தான். See that both are equal. Output of the system should be equal to system only when we are testing any system by impulse input. Clear? That's why I am repeating these things once again. Anyway, let us take our question. Now what is the question that was given to us? The Z transformation of a system h of z. Now this h of z value is given as z upon z minus 0.2 and its region of convergence is mod z less than 0.2, right? Did you notice? Then the impulse response in the sense what? Again we have to take inverse z transformation for this function, right? That's very simple. அவங்களே சொல்லிருக்காங்க the impulse response அப்படின்னு சொல்லிட்டு இது நீங்க டைம் டொமைனுக்கு திரும்ப கன்வர்ட் பண்ணீங்க அப்படினா see there. Let's see. Impulse response அப்படினா மீனிங் என்னன்னா see h of z value கொடுத்திருக்காங்க. You all have to notice h of z had been defined as, let me write the answer here once again. H of z can be defined as what they said, that is z upon z minus 0.2, right? I think that is 0.2 or 2. Let me check it. That is 0.1, right? And see there what they said. Sir, this is h of z. They said that is h of z. Now it's impulse response in the sense. It means impulse response in the sense in the input side time domain they are considering del of n. Whenever I am considering impulse response, at this case system is going to be equal to the value of output y of z. So y of z also will be equal to what? Z upon z minus 0.2 with respect to, whereas its input is going to be 1 only. That is what they said. Right now what will be its impulse response? Just if I take inverse Laplace transformation for this function, inverse z transformation, right? So let us see. If I take inverse z transformation எப்படி எடுப்பீங்க? That is very simple question, I know, right? But for understanding I am spending this much of time. So mod of z is clearly defined as mod of z less than 0.2. அப்படினா மீனிங் என்ன அப்படினா ஒரு சிஸ்டம் என்ன பண்ணிருக்காங்க அப்படினா இம்பல்ஸ் ரெஸ்பான்ஸால டெஸ்ட் பண்ண ஒரு சிஸ்டம். இப்போ இதோட இன்புட் திரும்ப இத நீங்க ரீகெயின் பண்ணீங்க அப்படினா உங்களுக்கு என்ன கிடைக்கும்னு கேக்குறாங்க. இத நீங்க அப்படியே ட்ரான்ஸ்ஃபர் பண்ணீங்க அப்படினா it is the actual output of whom step signals, right? It is the actual input of step signals. So impulse response like ஒரு சிஸ்டம்க்கு நீங்க this is the output. Just take the inverse Laplace Z transformation. What is the inverse Z transformation? That is nothing but, see there, can I write this function like this? Z upon z minus 0.2 can be rewritten as 1 upon 1 minus 0.2 into z power minus 1. Actually with this word region of convergence has been clearly defined as less than 0.2. I understood this is the impulse response of the step function. There was an impulse response system. That system would have been tested by step signal. That is step signal டெஸ்ட் பண்ணிருக்காங்க. இது நம்ம பாக்கும்போது ஆன்சர் தெரியும் இல்லையா? இதுக்கு நீங்க இம்பல்ஸ் ரெஸ்பான்ஸ் இதுக்கு நீங்க இன்வெர்ஸ் Z டிரான்ஸ்ஃபார்மேஷன் எடுத்தீங்க அப்படினா what will you get? Either you can write this function can be written as u of n. We can write u of n into 0.2 whole power n. That is correct. This function can also be written like this. It can also be written as minus 0.2 whole power n into u of minus n minus 1. Which is the correct answer? This is for left-sided signal. This is for left-sided signal, or I can say clearly if you want to define, that is called anti-causal signal. That is called anti-causal signal. Whereas this is for causal signal. This is for causal signal. Whereas for the causal signal, region of convergence should be greater than 0.2. For the anti-causal signal, region of convergence should be less than 0.2. So which is the correct answer? So the correct answer is this one. In a question pathona answer potrupinga, some of you, right? So anyway, some of you might not get the questions till now. So this is the correct answer for this one. If it is reverse, idu apdiye maati padinga, this is the correct answer. Okay. Option la iruka minus 0.2 whole power n into u of minus n minus 1. Option D is the correct answer for the given function. See, questions are very easy. இத எத்தனை ஸ்டெப் நம்ம போறோம் பாருங்க. 2 steps எல்லா क्वेश्चनும் அப்படிதான் இருக்கும். எல்லா சப்ஜெக்ட்டுமே அப்படிதான் இருக்கும். But the way that you are training your brain, that's very important. Okay, fine. Next term. The expression and the region of convergence of the Z transformation of a sampled signals are, right? I think some data is missing, right? The expression and the region of convergence of the Z transformation of a sampled signal. Just mark this one. After completing the sampling theorem, I will teach you this one. I think they are given some delayed version, right? Let me check it, right? Whether the data is missing or some other things beginning of this one. Just round pannikonga, question number 15, that is beginning of sampling theorem, right? I will check it because some data is missing. Directly we cannot complete the answer for this one. The expression and the region of convergence of the Z transformation of the sampled signal. Yeah, so I think some data is missing. Or otherwise, illa na vera engachu poitena. Oh, sorry guys, it is here, right? I am looking for 15th question. Okay, let us see. Question number 10, we have to see here, right? Cross. Question number 10 edukonga. Here data I did not notice. Fine. Question number 10, answer another. A causal LTI system is described by the difference equation twice of y of n equal to alpha into y of n minus 2 into x of n plus blah blah beta into x power n minus 1. The system is stable only if. டிஃபைன் பண்ணிக்கலாமா? சிஸ்டமோட ஸ்டெபிலிட்டி நம்ம முதல்ல எங்கெங்கெல்லாம் ஸ்டேபிளை பார்க்குறீங்களோ இப்போ எல்லாமே உங்கள் மைண்டில், அதுவும் இசட் டிரான்ஸ்ஃபர்மேஷனில் ஸ்டெபிலிட்டி பார்த்துட்டீங்க அப்படின்னா ஒரே ஒரு விஷயம் தான் மைண்டில் இருக்கணும். என்னது? யூனிட்டி சர்க்கிள் ஆர்ஓசிக்குள்ளே வரணும். அவ்வளோதான், வேறு எதுவுமே மைண்டில் இருக்கக்கூடாது. நீங்கள் ட்ரா பண்ணுற ஆர்ஓசியில் யூனிட்டி சர்க்கிள் கண்டிப்பாக எங்கே தான் வரணும்? இட் ஹேஸ் டு பி அண்டர் லைஸ் ரீஜன் ஆஃப் கன்வர்ஜென்ஸ்குள்ளே வரணும். இப்போ நீங்கள் ஓகே ஃபஸ்ட் நம்ம டிஃபைன் பண்ணலாம், ரைட்? கொடுத்துருக்க டேட்டாவை நான் கரெக்ட் பண்ணிக்கிறேன். லெட்ஸ் சே அதுக்கு நீங்கள் இன்வெர்ஸ் Z டிரான்ஸ்ஃபர்மேஷன் எடுத்து Z டிரான்ஸ்ஃபர்மேஷன் எடுத்துட்டு நம்ம ஆன்சர் என்னன்னு பார்க்கலாம், ரைட்? Let us see. The given is twice of y of n equal to alpha times of y of n minus 2 minus twice of x of n plus beta into x of n minus 1. Beta into x of n minus 1. The system is stable. Okay, அந்த கண்டிஷன் அப்போ பார்த்துக்கலாம். பிகாஸ் நமக்கு தெரியாது டைரக்டா, நம்ம இதை ரெடியூஸ் பண்ணா தான் தெரியும். செக் பண்ணிடலாமா? அப்படியே ஃபர்ஸ்ட் இதுக்கு ட்ரான்ஸ்ஃபார்ம் பண்ணுங்க. Z டிரான்ஸ்ஃபார்மேஷன் we all know what we know. First for that we name the property. என்ன ப்ராப்பர்ட்டி வேணும்? For x of n, its correspondent Z transformation can be defined as x of z. Exactly correct. If I have a function x of n minus n naught, then its Z transformation can be defined as z power minus n naught into x of z. Yes, this is correct. Let us go ahead. If the property apply பண்ணுங்க. For x of n, x of z. Similarly, if you know y of n, then its correspondent transformation, Z transformation is 2 times of y of z should be equal to alpha is a constant factor. You don't need to be panic. Y of n minus 2 can be written as z power, see there, minus n naught minus n naught. So minus 2 will go minus 2. Clear? Into y of z, yes, and minus 2 x x of n can be written as x of z, right, and plus beta into x of n power minus x of n minus 1 can be written as z power minus 1 into x of z. Shall we reduce this function further? Did you notice these things carefully? Inga y of z அப்படிங்கிறது usually output for our function. Y of z is the output of the function and x of z is the usually input of the function, right? So from this I understood. Just let us bring this down to the left hand side such that this function can be written as, let us club these things together. If I bring them left side, this become alpha times of z power minus 2 into y of z equal to minus 2. From this 2 you can take x of z outside plus beta into z power minus 1 into what I can suggest x of z. Now from this you can take y of z outside. So if I take y of z outside, this become 2 minus alpha into z power minus 2, right, equal to, it can be written as minus 2 plus beta times of z power minus 1 into x of z, right? Okay, let us place them. இது reduce பண்ணா இதுல இருந்து system எடுத்துவாங்க. System and output divided by input, right? Y of z is usually output of, that is common output, right? So y of z is usually output of the function and x of z is input of the function, right? Please wait a minute. It's really hard to do these things. Yeah. Now y of z upon x of z. Let us continue. Solve y of z upon x of z, in the sense this can be defined as 2 minus, did I make any mistake? Y of z divided by x of z. Upon yes, minus 2 plus beta times of z power minus 1 upon what it was given, 2 minus alpha into z power minus 2. எனக்கு எந்த டேட்டாவுமே கிடைக்கலங்க. அவங்க என்ன கொடுத்துருக்காங்களோ அந்த ஃபங்க்ஷனை அப்படியே நான் ரெடியூஸ் பண்ணுறேன். அப்படி ரெடியூஸ் பண்ணும்போது ஐ காட் சம்திங், எனக்கு ஒரு சிஸ்டம் கிடைச்சிருக்கு, அவ்வளோதான். எனக்கு வேறு எதுவும் ஐடியாலாம் கிடையாது. அவங்க என்ன கேட்டுருக்காங்க, ஸ்டெபிலிட்டி. இதில் ஆல்ஃபாவோட பீட்டாவோட வேல்யூ வச்சு தான் நம்ம ஸ்டெபிலிட்டி டிஃபைன் பண்ணோம் அப்படின்னு சொல்கிறாங்க, ரைட்? ஓகே, லெட் அஸ் கமிங் பேக். எனிவே, in order to define the stability of the system, right, we should talk about poles, because anyway we are in Z transformation. It does not matter at which transformation they are lying. Stability of the system will be decided by the poles. Now tell me, in our control system, throughout the system, right, when I have started the lecture from the beginning till the ending, at anywhere you can just go and check it, at anywhere did I talk about the location of the zero when I was talking about the stability of the system? System oda stability define பண்ணும்போது did I define or did I took or did I consider the effect of the zero location? Zero oda effect consider பண்ணி stability நம்ம எங்கயாச்சும் define பண்ணிருக்கோமா? No. So the system stability is depending on the location of the poles. It won't decide by zeros. Clear? Now what do you mean by zero? Zero in the sense numerator roots of the transfer function. See there, it is the transfer function. Let me define. Output divided by input is nothing but system only, na? So numerator of the system is defined as zeros, whereas denominator is called the polynomial function, that is simply called poles. That is called poles of the system, right? So from this, what could you understand? Let us reduce this function, right? So first take the numerator. From this numerator I have a 0, but now tell me, is there any purpose of investigating this 0? No, I can directly write, since beta is a 0, beta is a 0. So the correct answer is beta is a 0, beta is a 0, beta is a 0. Stability of this system cannot be decided, right? That is not cannot, we can say stability of the system won't be decided with the help of zeros. So beta won't be contributed in the stability, first conclusion, because it is a 0. Now I should talk about the pole. Let us proceed. So poles are the based on, just take this one, right? Poles for the value there, we have the equality to 0 minus 2 minus alpha z power minus 2. From this it is equal to 0. From this I can say 2 is equal to alpha into z power minus 2, right? This function can be further reduced to be 2 is equal to alpha by z square. From this function can be, okay, let me do these things. Find out the location of the poles, later we will decide. So the answer is what? Z square equal to alpha by 2. From this what I can say, Z equal to plus or minus under root of alpha by 2. Clear? That is the value that we got for this system. Now let us see. If you want to define the stability of the system, right? Our system வந்து stable இருக்கணும் அப்படினா it has to consider the effect of region of convergence. Yes or no? Yes. First thing is it should be restricted, right? So then only what will happen? Region of convergence will lies, that is your system is being converged whenever we are considering unity circle under ROC. That is very important. Right? Now from this given system, let us estimate the value of alpha. See there. Now this is the given pole, and anyway, just consider the magnitude of the poles, and with these poles only we are going to develop the region of convergence, right? So from this ROC we can define whether the given system is stable system or unstable system. For that we can define. Listen, let us take this function further, right? Some of you might not be confused. Let's get the friction here. Usually in the convergence formula நம்ம எப்படி டிஃபைன் பண்ணிருப்போம் அப்படினா it can be done like this. First term in the denominator we have 1 minus common factor. See, it is usually being written as 1 minus, but here we have 2. So let me take 2 outside. If there are 2 நீங்க வெளியில எடுத்தீங்கன்னா it is become what? This function can be written as 1 minus alpha by 2 into z power minus 2. Now just to notice these things. This function has to be alpha by 2 into z power minus 2 value should become less than 1. From this we can define it is going to be alpha by 2, right? Is going to be what? What we can suggest z square 1, or I can say alpha by 2 is going to be less than z square. Clear? So from this what we can suggest, right? We can pass this square from here, right? You can bring or otherwise let me take only consider positive value. Let us take in both sides if we are considering square root such that this become z. So z should be greater than the value of alpha by 2, right? In order to let your system to become stable. Now let us choose the value of alpha. If you alpha வந்து value choose பண்றீங்க அப்படினா alpha value எப்படி இருக்கும்? See there, if I choose alpha equal to, right, minimum value of alpha, let me define like this, right? If I choose alpha equal to, should try to understand because this is very simple. We found in course, but some of you might be confused. Sir, this actually எப்படி sir நான் define பண்றது? We can define it in terms of ROC. See there, what we have understood from this I understood, right? So from this I understood this is the condition. Now let us substitute some values for alpha. இப்போ நீங்க alpha க்கு value substitute பண்ணும்போது if the value of alpha is exactly equal to 2, let us see. If I substitute equal to 2, then 2 getting cancelled, then z will become greater than 1, right? Greater than 1 அப்படினா 1 க்கு வெளியில தான் ROC வரும். Now tell me, is it stable system? No. This is unstable system. Why? It is region of convergence existing outer of the 1 unit circle. 1 க்கு வெளியில வருது. So what I have to do? If I choose some value alpha as greater than 2, suppose alpha value 2 விட அதிகமா இருந்தா 2 விட அதிகமான see first I took alpha equal to 2. This is what I got, right? Suppose if I am getting some other value, slowly you will understand. Anyway, some of you might got the answer, I know, right? But you have to understand, right? Let me define. If alpha is greater than 2, then what I have? Just now I have written alpha is 3. For 3 important for best, let us take 4 எடுத்துக்கலாமா? If alpha equal to 4, because greater than 2 in the sense any value, 4, 6, 8, 10, 100, lakhs, anything we can consider. If I consider 4, then what will happen? Z should become greater than 4 by 2 will become 2 root 2. Root 2 value will become 1.414. So it is again sir greater than 1.4 of unity circle. 1.4 ஓட அதிகமா வரும். Such that so what is the conclusion? You cannot keep. So what is the conclusion here? Alpha oda value enna varakudadu appadina it cannot be 2 and it cannot be greater than 2. Then what will be the answer? Alpha should be less than 2. Getting me? If I keep alpha equal to 2, then system is unstable. Greater than 2 also system is unstable. For all value of greater than 2, system is unstable. Equal to 2 also system unstable. Then what is the minimum value of alpha? It has to be less than 2. It has to be less than 2. Then only if I keep, for example, alpha equal to 1. Let us choose. Alpha க்கு நீங்க 1 ன்னு போட்டீங்க அப்படினா what are you getting? 1 by 2. That is root of 1 by 2. That is become 1 by root 2 or 0.707. Such that your circle will start. That is your ROC will start. 0.707 க்கு greater than வரணும், right? So 0.707 இங்க இருந்து ROC வரும். See that now unity circle lies under ROC, system is going to be stable. So the finalized conclusion, beta does not contribute, it does not show its contribution in the stability of the system, whereas if the value of alpha less than 2, then the system is going to be stable. Okay, till now I have not noticed the options. Now let us read the options and we have to give the answer. Wait a minute. Okay, it is closed for me. Let me check it once. Where is the answer? option alpha should be less than 2. இங்க ஒரே ஆப்ஷன் தான் இருக்கோ. ஆப்ஷன் சி பீட்டா தான் நமக்கு தெரியுமே. பீட்டா யாரா இருந்தா நமக்கு என்ன, அது எனக்கு தேவையில்லை. ஸோ பீட்டா ஏதோ இருந்துருக்கு. ஆப்ஷன் கரெக்டாக பொறுத்துதான். எனி வேல்யூ ஆஃப் பீட்டா ஓகே, ஐ டோன்ட் need to panic, but alpha should be less than 2. Yes, so the exact answer is option C. Proceed பண்ணலாமா? நெக்ஸ்ட் பாருங்க, the region of convergence. Happily you might give the answer. Question number 11. I hope in answer பண்ணிருப்பீங்க நம்புறேன். நம்ம செக் பண்ணிடலாமா? Yes, let us testify. ROC என்ன வருதுன்னு பார்க்கலாம். Right, so let me rub this one. Please wait for a few seconds because it's really very hard. Yeah, it's okay. What it was given? Where is question? 5 by 6 whole power n, 6 by 5 whole power n. Just reciprocal, right? So the given it is what? 5 upon 6 whole power n with u of n. That is causal signal, right side signal, minus 6 upon 5 whole power n into u of minus n minus 1. That is anti-causal signal. 6 by 5 whole power plus n only now. Yes. Can anyone define the answer? Yes. Check pannilama. Yes. First thing, it is the right side signal. So its region of convergence should be right signal greater than what? 5 by 6. First conclusion is what? This is what? Left side signal. Apollo's region of convergence, left side means less than. How much? 6 by 5. Shall we draw the ROC? Yes. Now, the thing is, 5 by 6. Can anyone tell me the equivalent value? If I cancel 5 by 6, it is going to be 0.8 and then 3 and then again we are going to get, anyway that is 0.833, right? Fine. What about 6 by 5? That is 1.2. So what is the conclusion? This is the first value. Select the compass. Once again, take your compass, select the radius as 0.833, right? Let us draw the first circle with the value of 0.8333, or we can say 5 by 6, right? That is 5 by 6. And its ROC is what? It is greater than 5 by 6. In the sense, its region of convergence will go like this. That is the region of convergence. Next, second person. 6 by 5. Again, take a compass, draw the radius, right? With the 6 by 5 in the sense 1.2. It is only 0.833. Where is 1.2? It is somewhere here. Right? So 1.2 in the sense, let us consider that is 1.2 or 6 by 5. What about its ROC? Its ROC is less than 6 by 5 in the sense it is going like this. It is going like this. Now, whenever while having more than one pole, you will have to choose the common ROC, right? Rendu perum enga overlap aayirukanga. Say the overlapping portion is this one, right? So the correct answer is what? Region of convergence should be restricted in between what? We can say 5 by 6 to 6 by 5. That is the correct answer. Where is the option? Option 5 by 6 to 6 by option C, right? Next, what happens if the region of convergence of x1 of n plus please wait a minute. It is closed for me. Question number 12 only now. Yes. Then the region of convergence of x1 of n plus x2 of n is different as 1 by 3 to z by 3. The region of convergence of x1 of n minus x2 of n. இப்போ கவனிங்க, இங்க பாருங்க, இங்க ஒரு தான் மைனஸ் இருக்கு. நான் இந்த மைனஸ் எங்கேயாச்சும் கன்சிடர் பண்ணிருக்கேன். இது வரைக்கும் நீங்க யோசிச்சு பாருங்க. நான் அங்கேயே சொல்லியிருந்தேன், இதுக்கும் இது சம்மந்தமே இல்லை. நமக்கு இது u of minus என்ன, u of plus என்ன, அது மட்டும் தான். ரைட் சைடு சிக்னல், லெஃப்ட் சைடு சிக்னல். I don't need to worry about the magnitude at all. So what is the ROC? Magnitude scaling magnitude scaling in a sense. Your signal is being multiplied by, that is amplified signal, right? Magnitude scaling அப்படினா signal வந்து நீங்க scale பண்றீங்க. It might be -1 or -2 +1 +2 +10. It does not change the region of convergence. So what is the correct answer? Questionல என்ன கொடுத்திருக்காங்களோ அதுதான் answer. Questionல என்ன கொடுத்திருக்காங்க? 1/3 to 2/3. அப்ப answer என்ன? 1/3 to 2/3. Answer is what? Option D. Yes. Right, there is no changes. அது change ஆக போகுது அவ்வளவுதான். அடுத்த क्वेश्चन எடுத்துக்கலாமா? What is this? The Z transformation x of z of a sequence x of n is given by x of z equal to 0.5 upon 1 minus 2 into z power minus 1. Okay, it is given that the region of convergence of x of z includes the unity circle, then the value of x of 0 is what? First tell me whether what type of system it is. It is what? Its region of convergence includes unity circle, the region of convergence vandirukku, and they are asking you the value of x of 0 is dash. If you want to know the value of x of 0, that is in the time domain we have to know these things. Okay, இப்போ இதுக்கு z transformation எடுத்தீங்க அப்படினா என்ன வரும்? Anyway, let us see. இதுக்கு z transformation 1/1 minus 2 into z power minus 1. One by 1 minus 2 into z. மேல ஒரு 0.5 இருக்கு. That is not, I don't want to be panic about that one. 0.5 upon 1 minus 2 into z power minus 1. What is the inverse z transformation? So its inverse z transformation, it's depending on the ROC, region of convergence. Define பண்ணலாமா? ROC வந்து நம்ம ரெண்டு விதத்துல டிஃபைன் பண்ணலாம். Don't be worry about this 0.5. That is simply a magnitude. That's all. அது எனக்கு தேவையில்லை. எனக்கு தேவை 1/1 minus 2 into z power minus 1. இதில் ROC என்ன வரும்? See, there are two chances. Either this region of convergence might be, let us define. அப்போ இதில் வேலை என்ன இருக்கலாம்? Mod of 2 into z power minus 1. Anyway, it is going to be less than 1. Its value is going to be less than 1 only, right? So from this I can define 2 upon z power minus 1 should be what? Less than 1. Right? Such that, sorry, it is plus 1, right? Such that this function can be bucketed as 2, it should be what? Less than z. Or we can say its region of convergence ROC should be what? It is going to be greater than 2. If I just go with this data, if I just go with this given data, then what I will do? If I just go with this data, if I just draw the region of convergence, since given it is, yes, for the given function only I have drawn the, that is I took the region of convergence, but I understood it is going beyond 2. இப்போ நீங்க டைரக்டா இந்த region of convergence வரீங்க அப்படினா, that is what? Of course that is correct only, but this is something, right? This is something, some black thing. Enna it is 2 into z power minus 1, everything is perfect, right? It is given that the region of convergence of the x of z includes the unity circle. Inga unity circle enga irukku? It lies in the inga unity circle. ஆனா எனக்கு கொடுத்திருக்க கண்டிஷன் படி இத வச்சு பார்க்கும்போது I am not getting that function, right? அப்ப எனக்கு என்ன வருது பாருங்க, it is going out of this zone, right? It is just traveling towards beyond 2, greater than 2. So what should I do now? If we want to find out, okay, I have to consider x of 0 oda value வந்து நீங்க ஃபைண்ட் பண்ணனும்னா, okay, unity circle இதுக்குள்ள நீங்க கன்சிடர் பண்ணனும் அப்படினா what we have to do? I will have to reverse the property of this signal, right? So given it is the causal signal. Anyway, given it is the causal signal and I should restrict them, right? இப்போ இந்த வேல்யூ நீங்க என்ன மாத்தணும் அப்படினா, if you are changing this property, right? இப்போ இது causal இருக்குன்னா anti causal மாத்துனீங்கன்னா, okay, happily you can say that system will become a stable system, right? So let me do it. Sir, according to the given data, this system is unstable. Why it is unstable? Because unity circle lies outside. Unity circle inga irukku, ana ROC velila pogudu. So this is wrong. I have to reverse the property. So I am just changing this signal. I understood. It is the this system. It is the for is a transformation of u of n. But with this my system is unstable. ஆனா அவங்க ரெஸ்ட்ரிக்ட்டடா ஒரு கண்டிஷன் கொடுத்திருக்காங்க. Your system has to be stable அப்படினு சொல்லிருக்காங்க. அப்ப அது ஸ்டேபிள் அப்படினா you have to reverse it, right? அப்ப region of convergence நீங்க மாத்தணும் அர்த்தம். entire system property நீங்க மாத்தணும். It means system வந்து நீங்க ஸ்டேபிள் சிஸ்டமா கன்சிடர் பண்ணனும் அப்படினா given system directly, if I am defining the ROC directly, it don't say that the system will be unstable. But later I understood they said maintaining a system as a stable system or maintain பண்ணனும் சொல்லிருக்காங்க. For that I am interchanging. அவங்களே சொல்லிருக்காங்க அந்த கீயை எடுத்துட்டு நான் ப்ரொசீட் பண்றேன். அப்ப அது ஸ்டேபிள் சிஸ்டமா மாறணும் அப்படினா சிக்னல் காசலா இருக்கிறது ஆன்டி காசலா மாறணும். காசல்னா 2 விட வெளிய போகும். ROC will going out of 2. இத நீங்க ஆன்டி காசலா மாத்திட்டீங்கன்னா if it is interchanged, right, if it is changed to anti-causal, then your system will become stable. Why? Because see, this is 2. Where is unity circle? It is lies under ROC. Now this system is correct. This system is going to be a stable system. In this stable system, you are requested to calculate the value of x of 0. Can anyone tell me the answer for this one? Anti-causal system la x of 0 oda value evanga 0. Yeah, wave from range நமக்கு தெரியுமே. Anti-causal signal எப்படி ரெப்ரசன்ட் பண்ணுவீங்க? u of -n - 1. yes or no? இதோட லிமிட் எவ்வளவு? இதோட லிமிட் நீங்க எப்படி டிஃபைன் பண்ணுவீங்க? see, let me define. Actually this function value will be defined as, right, u of -n - 1 can be defined as, you can consider its function value as 1, whereas its limit should be restricted as, we are only drawing from -∞ to -1 and this 0 elsewhere. yes or no? Question என்ன கேட்டிருக்காங்க? ஆரிஜின்ல என்ன வேல்யூ கேட்டிருக்காங்க? If it is a step signal, then your answer is 1. That is causal. In the system la, right, see, this is causal signal. For this you can define like this. This value is going to be 1, whereas the limit n should be maintained as 0 to infinity, and it will be 0 elsewhere. Actually கொடுத்திருக்கிறத வச்சு பார்த்தா இதுதான் எனக்கு ஆன்சர். ஆனா இது கூட ஒரு ஸ்டேட்மென்ட் ஸ்ட்ராங்கா ரெஜிஸ்டர் பண்ணலாம். That is the key. கீ பாயிண்ட் இங்க தான். நீங்க இத வச்சு என்ன பண்ணீங்கன்னா நீங்க செக் பண்ணாம டைரக்ட்டா நீங்க என்ன பண்ணலாம்? இது ஸ்டெப் சிக்னல் கண்டிப்பா ஆரிஜின்ல எக்ஸிஸ்ட் ஆகும். just you can directly put that answer, that is wrong. You can put, if you are putting the answer, then that is wrong. What you have to do? You have to testify the signal, right? So now the system வந்து stable system னு கொடுத்திருக்காங்க. இது ஸ்டேபிளா இல்லையே. அப்ப சேஞ்ச் பண்ணனும். ப்ராப்பர்ட்டி சேஞ்ச் பண்ணிட்டான்னு அர்த்தம். இன்டீரியர், right? So from this I understood x of 0 in the sense there is no 0 la exist ஆகாது. 0 is existing causal signal. In anti-causal we are running up to -1 only. So the correct answer for this function is 0. So you have seen on publication today morning or I think somewhere. For this question they have done some blah 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 things. Finally they did many things and then finally they write the answer for this given function. Answer is going to be 0 with some derivations, blah things, story. Is it required? Why it is required? எவ்வளவு அழகா கீ பாயிண்ட் கொடுத்து வச்சிருக்காங்க. you are looking for entrance exam. You will be tested with smartness. உங்களோட brain எவ்வளவு ஸ்மார்ட்டா வர்க் பண்றதா செக் பண்ணுவாங்க. you have to think. அது எப்பவுமே மைண்ட்ல இருக்கணும். அவ்வளவு பெரிய டெரிவேஷன் அங்க தேவையில்லை. you have to think. என்ன லாஜிக் இருக்கு பிஹைண்ட்ல? ஒரே ஒரு சிஸ்டம் தெளிவா கொடுத்திருக்காங்க. that is stable system. So just reverse the property, put the answer. It's over. Clear? So the correct answer is 0. Okay, take the next question. What they get in the following network, the switch is closed. I think it's a very very good question. Check பண்ணிடலாமா? Because I have seen it long time ago, or 1.5 years already. Let's see. In the following network, the switch is closed at t equal to 0 and the sampling starts from t equal to 0. Okay. The sampling frequency is given as 10 Hz. Okay. The samples, okay, n equal to 0, 1, 2, 3 is our standard samples, because in discrete domain we are considering 1, 2, 3, 4 like that only we are doing the sampling. Question நல்லா நோட்டீஸ் பண்ணி பாருங்க. என்னென்ன பண்ணிருக்காங்க பாருங்க. sampling theorem உள்ள வந்திருக்கு, Z transformation உள்ள வந்திருக்கு. நெட்வொர்க் அனாலிசிஸ்ல ஒரு RC சர்க்யூட்டை DC ல கனெக்ட் பண்ணா என்ன நடக்கும், நம்ம எப்படி செக் பண்ணுவோம் அப்படிங்கற டெர்ம்ஸும் உள்ள வந்திருக்கு. கரெக்ட்டா? எஸ். happily they are given many things here, black things. So from this let us testify. Question என்ன கேட்டிருக்காங்க அப்படினா, sampling frequency is given as 10 Hz, then the sample x of n are given by. Question number 1 is sample என்னன்னு கேக்குறாங்க. இப்போதான் அந்த question number 2 வந்திருக்கு. நான் சொன்னேன் டேட்டா மிஸ் ஆயிருக்குன்னு. The expression and the region of convergence for the Z transform of this sampled signal is dash. Anyway, that is the given question, right? So I am requesting you all first RC circuit நீங்க எப்படி output find பண்ணுவீங்க? You all know. Wait a minute, it is again. Yeah. Please wait for a while. Fix it. Question number 18 is, okay, you can just do it. Find out the output expression. RC circuit மட்டும் தனியா எடுத்துட்டு RC circuitல ரெசிஸ்டர் அக்ராஸ் வோல்டேஜ் கண்டுபிடிங்க. You just do it. Let me bring the answer. RC circuit வருது அப்படின்னா across the capacitor நீங்க சொல்லலாம் சார் capacitor across ஃபார்முலா நமக்கு தெரியும். Whenever a DC or your RC circuit is being excited by DC supply, then the voltage drop across the capacitor can be defined as Vc of t is equal to Vc of infinity plus Vc of 0 minus Vc of infinity into e power minus t by 2. I am really very happy that I know. But that is the voltage drop across the capacitor. How will you find out the voltage drop across the resistor? KVL. General expression கெபாசிட்டருக்கு general expression ஃபைண்ட் பண்ணிட்டீங்க அப்படின்னா net supply voltageல இருந்து கெபாசிட்டர்ல இருக்க voltage சப்ட்ராக்ட் பண்ணீங்கன்னா do you get the voltage across the resistor or not? That's all. Just do it. Find out the answer. Find the voltage drop across the capacitor. Please let me know. Okay, anyway, let me try to solve this question, right? One question I will solve, second question I am just giving to you. Yes, let us proceed. It's really very easy question, right? நீங்க diagram பார்த்தோம்னா you might be wondering என்ன இவ்வளவு கஷ்டமா இருக்கு like that. You think like that. அது உங்களை think பண்ண வைக்கிறது தான் அவங்க வேலை. diagram பார்த்தோம்னா பாதி பேர் question skip பண்ணிடுவாங்க, right? Without reading that question. Let's see how easy that question is. What is the question number? Yes, question number is question number 14, right? Yes. First, let us take this circuit. Given is a DC supply with the capacitor. Yes, with the capacitor. Switch எல்லாம் இருக்க போல எல்லாத்தையுமே கன்சிடர் பண்ணிடுவோமா? Yes, let us consider switches. See, is there any problem in the class? I think class is going good. Edachi issues irundha just to make a WhatsApp call. I think someone calling me. If any of you have any problem, please just make immediate WhatsApp call because now I cannot see you all. 10 microfarad. This is given us. Anyway, till now நம்ம sampling theorem இன்னும் பார்க்கல. அவ்வளோ பெரிய தியரம் இங்கே தேவையில்லைன்னு நான் நினைக்கிறேன். செக் பண்ணிக்கலாமே. ஓகே, இதுக்கப்புறம் சாம்பிளிங். ஓகே, அதை நம்ம அப்புறம் பண்ணிக்கலாம். ஃபஸ்ட்டு எனக்கு என்ன தேவை அப்படின்னா கவனிங்க, இங்கே நமக்கு இந்த ரெசிஸ்டருக்கு அக்ராஸாக கிடைக்கிற வோல்டேஜ் தான் தட் இஸ் கோயிங் டு பி தி இன்புட் ஃபார் யுவர் சாம்பிளர், ரைட்? சாம்பிளருக்கு இங்கே யார் இன்புட்டாக போவோம் அப்படின்னா இந்த இடத்துல என்ன வோல்டேஜ் ட்ராப் ஆகுது தட் இஸ் கோயிங் டு பி தி இன்புட் ஃபார் யுவர் சாம்பிளர். கேன் யூ ப்ளீஸ் ஃபைண்ட் இட்? எஸ். ஃபார் தட் we have to take supply voltage is given as 5 voltage. We are closing the switch at t equal to 0. It was clearly given, right? So let us express directly. Whenever I am looking for RC circuit, we cannot find out the voltage drop across the resistor. Adu find panna mudiyadhu, but we can find out the voltage drop across the capacitor. What is the formula? The formula is Vc of t can be written as Vc of infinity plus Vc of 0 minus Vc of infinity into e power minus t by tau. Exactly, that is correct. Let us estimate. Vc of 0 minus is 0 because they did not give any initial voltage drop across the capacitor. Final voltage is what? After closing the switch at t equal to infinity, capacitor will be open circuit. If it is open circuit, then the supply voltage simply dropped across the capacitor. See there. Let us forget about this sampling and all. Just to take this circuit first, right? So what happens here? At t equal to infinity, this capacitor will be open circuit. If it is open circuit, then current supplied by the source will going to be 0 ampere at open circuit. If it is 0, then do you find any voltage drop across the resistor at the steady state? No. At t equal to infinity, current supplied by the source is going to be 0, such that the current entering into the resistor also going to be 0. So the voltage drop across the resistor also is going to be 0 at t equal to infinity. If the voltage drop across the resistor is 0, but from the supply we are getting 5 voltage, so that 5 voltage will be blocked by whom? Capacitor. So capacitor is blocking that 5 voltage. So 5, it is 0 minus 5. So minus 5 into e power minus t by tau. Let us estimate the value of tau also. Tau is equal to R into C. What is the value of R? R is 10. What is C? It's 200 kilo ohm. Sorry, 200 kilo ohm is what? Kilo ohm means 10 power 3 into capacitor is what? 10 microfarad. Micro means 10 power minus 6. Now see there, positive 10 power 3 into 10, 10 power 4 into 1 more 100, 10 power 6. So இது எல்லாத்தையுமே add பண்ணீங்கன்னா 10 power minus 6, 10 power plus 6 will be cancelled. Finally it will become equal to 2 only. So tau is become 2. Next, what I have to do? I hope you all remember. Anyway, till now I did not. Tomorrow we are going to start what I can say sampling theorem and just giving introduction. I hope you all remember. When you basic signals வந்து அப்சர்வ் பண்ணிருந்தீங்கன்னா நான் அடிக்கடி ஒரு விஷயத்தை பேசியிருக்கேன். ஆக்சுவலாக டிஸ்கிரீட் டொமைன் அப்படிங்கிறது நேச்சுரலாக அப்படி ஒரு டொமைனே கிடையாது. யூனிவர்ஸில் டிஸ்கிரீட் டொமைன் அப்படின்னா ஒன்று கிடையவே கிடையாது. இப்போ நான் பேசிட்டு இருக்க சிக்னல் தட் இஸ் கண்டினியூஸ், பட் தட் கண்டினியூஸ் சிக்னல் will be discretized, sampled. That is called discrete. We are designing the discrete system with from the sampling. கண்டினியூஸ் டொமைன்ல இருக்க ஒரு சிக்னலை நம்மளால சிஸ்டம்ல ஸ்டோர் பண்ண முடியல. ஏன்னா அதுக்கு அதுல கண்டினியூஸ் டொமைன்ல இருக்க இன்ஃபர்மேஷன் வந்து ரொம்ப அதிகமா இருக்கு. அவ்வளோ இன்ஃபினிட் இன்ஃபர்மேஷன்ஸ் நான் எப்படி சேவ் பண்ண முடியும்? அதுக்காக கொண்டு வந்தது தான் டிஸ்கிரீட் சிஸ்டம். அப்போ டிஸ்கிரீட் சிஸ்டம்ல நம்ம சாம்பிளிங் பண்ணணும். தட் இஸ் கால்ட் சாம்பிளிங். தட் ப்ராசஸ் இஸ் கால்ட் சாம்பிளிங். கண்டினியூஸ் டொமைன்ல இருக்க ஒரு சிக்னலை நீங்க டிஸ்கிரீட்டுக்கு மாத்துறீங்கல்ல, தட் ப்ராசஸ் இஸ் சிம்பிளி கால்ட் சாம்பிளிங். Okay, yes, let us go ahead. First I will complete, right? I will tell you first இது முடிச்சதுக்கு அப்புறம் சாம்பிளர் என்ன பண்ணனும் அப்படிங்கறத நான் சொல்லி தரேன், right? Tomorrow we will see rest of for things. It's very easy sampling process. Okay, இப்போ நம்ம என்ன பண்ணனும்? நம்ம இப்போ voltage drop across the capacitor find பண்ணியாச்சு, கரெக்ட்டா? But I don't want this one. What I want? I would like to know the voltage drop across the resistor. Because across the resistor only we are connecting the sampler. So the voltage drop across the sampler will going to voltage drop across the resistor will going to the input of the sampler. Shall we proceed? Yes. So the voltage drop across the resistor VRT, VR of T, I would like to know this one. For that, from this supply, if you apply KVL, this is supply voltage with the 5, right? And the current is going like this. Current 18 point plus 20 point is minus for a capacitor. Let us define that is VC of T. Now, how will you find out the voltage drop across the resistor? According to KVL, we can simply say total supply voltage, right? So let me define 5. Total supply voltage 5 should be equal to voltage drop across the capacitor plus voltage offered by the resistor. That is KVL. From this what I can say? From this you can say the voltage drop across the resistor is going to be 5 minus VC of T, right? Substitute பண்ணுங்க 5 minus, where is VC of T? This is VC of T. If I substitute, it is become plus 5 minus 5 into e power minus t by 2. See that if you open up the bracket, 5 minus 5 plus 5 into e power minus t by 2. In the minus உள்ள பாஸ் பண்ணீங்கன்னா it will become minus 5, it will become plus 5, it is getting cancelled. Finally we are getting 5 into e power minus t by 2. Clear? So what is the conclusion here? The voltage drop across the resistor VR of T can be defined as 5 into e power minus t by 2. Clear? That is the voltage drop across the resistor. I hope these things are very clear to you all. Now this is going to be input to your sampler. In your examination you will take very நீங்க டயகிராம் பார்த்த உடனே ஆன்சர் போடணும். RC சர்க்யூட் என்ன உங்களுக்கு அவ்வளவு ஃபெமிலியரா இருக்கும் because long time ஆயிடுச்சு, ரைட்? என்ன சர்க்யூட்டை பார்த்த உடனே இதெல்லாம் நீங்க வரைஞ்சிடணும். VCR infinity, VCR 0 minus 1 second how to bring the voltage drop across the resistor. Let us take the second system. Second, actually these things, right? இதோட output இப்போ நம்ம எங்க பாஸ் பண்ண போறோம் அப்படினா through into the sampler, right? Now this is going to be the input of this sampler, right? Sampler circuit வந்து என்ன பண்ணோம் அப்படினா it will sample continuous domainல இருக்க இந்த values discrete domainக்கு மாத்தி விட்டுறோம். அவ்வளவுதான். Let us see. Let me rub these things. Now we know the outputs, right? RC circuitல கிடைச்ச output இப்போ நம்ம sampler circuit வழியா பாஸ் பண்ணோம் அப்படினா let us directly take sampling. Let us take VC of T. That is this one, right? Resistor output, resistor drop ஆகிற voltage தான் sampler வழியா போக போகுது, right? So the value is what? E power minus t by 2. இப்போ இந்த சர்க்யூட்டை when we are passing it through the sampler, right? Through the sampler ஓட frequency கொடுத்துட்டாங்கல? Yes, let me define how much it is. Something they said 10 hertz. Yes, that is 10 hertz only. So this sorry for the interruption. Sample is called what? 10. Sample frequency is 10 hertz, right? So let us proceed. Sample என்ன பண்ணோம் அப்படினா listen guys, listen. Time domain la irukka or signal, right? If you have any signal in continuous domain as x of t, நீங்க basic signals பார்த்தீங்கன்னா அதை டீச் பண்ணிருப்பேன். By transforming the signal, continuous domain la irukka or signal நீங்க discrete domain க்கு மாத்தணும் அப்படினா this t will be replaced by n into t, where n denotes the discrete domain value. In discrete domain நம்ம என்ன தான டிஃபைன் பண்ணுவோம்? With t denotes the sampling interval, right? Time period. எவ்வளவு டைம்ல வந்து நீங்க டிஸ்கிரீட் பண்ண போறீங்க, எவ்வளவு டைம்ல, right? So that is the fundamental time period of the discrete domain signal. So generally it will be denoted as x of n finally, right? X of n equal to x of nt only. Don't be panic. But this t is fixed. T t is the interval that will be fixed. ஒரு particular width நம்ம கிரியேட் பண்றோம். For example, if n equal to 1 ன்னு இருக்குன்னு வெச்சுக்கோங்க. இப்போ நான் வந்து இதோட width வந்து 0.1 ஆ மாத்தணும். அப்ப என்ன பண்ணுவாங்க அப்படினா it will be scaled. இப்போ இந்த n வந்து t ஆல மல்டிப்ளை பண்ணுவாங்க. t ஓட வேல்யூ வந்து 0.1 ஆ மாத்திடுவாங்க. t 0.1 நீங்க ஃபிக்ஸ் பண்ணீங்கன்னா 0.1 into 1 will become 0.1. So in order to compress or expand the signal, it is always being what? Multiplied by a fundamental time period, right? So and the time period வந்து fixed. T didn't define the time period, right? Okay, let us see. So that is how we are transforming a signal from continuous domain to discrete domain. This is very important process. Of course, it is very easy. This is not the new thing. நீங்க signals பார்த்திருக்கும்போது நான் திரும்ப அதை அங்க நடத்திருப்பேன், right? Yes, let us see. Anyway, tomorrow I will take these things once again. No problem. அப்ப சாம்பிளர் வழியா நீங்க இத பாஸ் பண்ணீங்க அப்படினா see that this is my signal, right? அப்ப நம்ம என்ன பண்ணலாம், இத அப்படியே அப்ளை பண்ணுங்க according to this concept, right? Through this sampler if I pass this one, then this become x of t can be written as bs of t can be written as, okay, first let us substitute this value 5 into e power minus t by 2, correct? இத சாம்பிளர் வழியா நீங்க பாஸ் பண்றீங்க அப்படினா சாம்பிளர்ல t will be replaced by what? n into t, such that this function will become Vs of n. I am writing it. See that I said n of t should be derived as Vs of n should be equal to this function can be written as 5 into e power minus n times of t by 2. Is there any mistake? No. T, just this t I get replaced by n into t. Next, I said this t denotes the fundamental period. It is reciprocal to the frequency. Now frequency is given as 10 Hz. So 1 by 10 should be equal to 0.1 second. Such that this value will become, it can be further written as 5 into e power minus 0.1 times of n by 2. Now 0.1 divided by 2, இது நீங்க எப்படி டிஃபைன் பண்ணுவீங்க? It can be defined as 0. I cannot directly cancel this one, right? So it can be 0.05, right? இன்னொரு 0 ஆல மல்டிப்ளை பண்ணீங்க அப்படினா see what will happen? 2, right? I am multiplying it by 10 into factor நாங்க கொண்டு வரோம். 0.1 you cannot directly cancel it by 2, right? So அப்படினா you can do like this. If you have any doubts, 0.1 into 1 by 2 நம்ம 0.5 எழுதலாம். 0.5 into 0.1 will become 0.05. That's all. Don't think too much, right? Normal calculation. So after sampling, your output is going to be Vs of n is going to be 5 into e power minus 0.05 times of n. Yes, we got the answer happily, right? And we have started our journey. Do you remember circuit நீங்க எப்போ க்ளோஸ் பண்ணீங்க? We have been closed our signal circuit at t equal to 0. Do you remember? RC circuit இருக்குல்ல, அதை எப்போ க்ளோஸ் பண்ணாங்க? t equal to 0 ல தானே. அப்பதான் நீங்க சாம்பிள் கொடுத்தீங்க. So can I multiply by u of n? Is there any mistake? அது எப்படி நீங்க u of n ல மல்டிப்ளை பண்ண முடியும்? u of n அப்படிங்கிறது it's a signal, its value is 1 and it is running from 0 to infinity. So in discrete domain, இப்போ என்னோட சிக்னல் எங்க இருந்து டிராவல் பண்ணது? t equal to 0 ல தான் RC circuit நம்ம க்ளோஸ் பண்றோம். அந்த டைம்ல தான் சாம்பிளிங் குள்ள வந்து வேல்யூ வந்து என்டர் ஆகுது, ரைட்? So the conclusion is what? I can multiply the signal by u of n. u of n value is 1. Its period is restricted from 0 to infinity. Of course this signal period is restricted from 0 to infinity only. So we can multiply by u of n happily. Why? Because my system RC circuit நம்ம t equal to 0 ல தான் க்ளோஸ் பண்ணோம். அந்த டைம்ல 0 ல இருந்து infinity வரைக்கும் தான் நம்ம டெஸ்ட் பண்ணிட்டு இருக்கோம் சர்க்யூட். So 0 to infinity ல exist அந்த signal is called step signal. So this function can also be multiplied by u of n. இப்போ அடுத்ததா யார் வர போறா? First RC circuit எடுத்தாச்சு. அடுத்து sampler வழியா பாஸ் பண்ணி அவுட்புட் எடுத்தாச்சு, right? So this is the sampler. We got the output of the sampler. So in the output, so இங்க எனக்கு என்ன கிடைக்கும் அப்படினா Vs of n. இப்போ இந்த sampler ஓட அவுட்புட் என்ன வந்திருக்கும் அப்படினா 5 into e power minus 0.05 times of n. That is the output of this sampler. அடுத்து என்ன பண்ண போறீங்க? sampler ல இருந்து நமக்கு கிடைச்ச அவுட்புட் Z transformation வழியா பாஸ் பண்ண போறோம், right? So we are in n domain. If I pass it to the Z transformation, see how beautifully they are taking the question, right? Happily you can solve. Nothing is there to understand. Only basics should be required. Is there any new thing that I am introducing? Basics of the network we know. Basics of the sampling we know. Right now basics of the Z transformation also we know. So we can solve the question easily. Is it worth for 4 mark? So there are two questions, right? There are two questions. Now is it worth for 4 mark? But the thing is, you know, many of the guys will leave this type of questions. That is they want, right? They will frame easy questions but in a different approach. Fine. Finally, happily you can pass it through the sampler now. That is 5 into e power 0.05 times of n into u of n. That is the output of the sampler. இப்போ இத யார் வழியா பாஸ் பண்ண போறீங்க? Z transformation வழியா பாஸ் பண்ண போறீங்க. அப்படினா மீனிங் என்ன? Z transformation அப்படினா இது it's a system. இங்க நாம என்ன பண்ண போறோம்? If you have any signal in the n domain, that domain value will be transformed into Z domain. That's all. Z transformation என்ன பண்ணும் அப்படினா டைம் டொமைன்ல இருக்க சிக்னலை Z domain க்கு மாத்தி வைக்கும். Shall we do it? Yes. That is the finally what we are going to do now, right? So let us see. If you want to know the Z transformation, we all know, right? If I have u of n into a power n, its correspondent Z transformation can be written as 1 upon 1 minus a into z power minus 1. Is there any mistake in my conclusion? No. And since its region of convergence is what? Its region of convergence is Z, ROC. ROC it should be greater than the value of, right? We can say e power minus 0.05. Right? Just whichever the value that we are giving here, we are going to consider that one. Right? So it has to be greater than 0.05. Right? So let us proceed with this. Or we can say, you can also be different as 1 by e power 0.05. நான் என்ன சொல்லிருப்பேன் மைனஸ் ஒன்று ரெசிப்ரோக்கல் எடுத்துக்கோங்க அப்படின்னு நான் சொல்லியிருப்பேன். டோன்ட் பி பேனிக், நீங்கள் ரெசிப்ரோக்கல் எடுத்தால் என்ன வரும்? இட் இஸ் இ பவர் 0.05 ஒன்லி. இது மேலே கொண்டு வந்தீங்கன்னா இ பவர் மைனஸ் 0.05. ஐ டோன்ட் நோ, டில் நோ ஐ டிட் நாட் லுக் அட் யுவர் ஆப்ஷன்ஸ், எப்படின்னு தெரியல, நம்ம செக் பண்ணிக்கலாம். எனிவே see that இங்க 5 ஆல மல்டிப்ளை பண்ணா அவுட்புட்டும் 5 ஆல மல்டிப்ளை ஆகும். தட்ஸ் ஆல். and then this function இங்க என்ன வரும்? for e power minus 0.05 into u of n, answer is going to be 5 divided by 5 is a constant factor divided by 1 minus value of a is how much? E power, right? See there, that is minus 0.05, or we can consider 1 by e power minus 0.05, right? So that is a, this is a, this is a, z inverse. So we are going to consider z inverse with the region of convergence is ROC, defined as greater than e power minus 0.05. Hopefully you all have understand. இப்போ செக் பண்ணலாமா? ஆப்ஷன்ஸ் இருக்கா பாத்தீங்களா? ஃபர்ஸ்ட் क्वेश्चनக்கு வந்து 5 into அத நம்ம வந்துச்சு இல்லையா, சாம்பிளரோட அவுட்புட் என்னன்னு கேட்டிருந்தாங்க. திஸ் இஸ் தி சாம்பிளர் அவுட்புட், தட் இஸ் வாட் 5 into e power minus 0.05, ஆப்ஷன் பி ஃபர்ஸ்ட் क्वेश्चनக்கு. செகண்ட் क्वेश्चनல வந்து என்ன கேட்டிருந்தாங்க? செகண்ட் क्वेश्चनக்கு வந்து z டிரான்ஸ்ஃபார்மேஷனோட அவுட்புட். லிசன், இந்த z இன்வெர்ஸ் நீங்க எப்படி மாடிஃபை பண்ணனும் உங்களுக்கு தெரியும் இல்லையா? ப்ளீஸ் டு இட். z இன்வெர்ஸ் நீங்க டினாமினேட்டர் பாஸ் பண்ணீங்கன்னா it will become z, கிராஸ் ப்ராடக்ட் பண்ணீங்கன்னா it will become z, whole divided by z னு அது மேல பாஸ் பண்ணீங்கன்னா happily you are getting the answer 5 times of z divided by z minus e power minus 0.05. right? Now what is the answer? 5 times of z divided by z minus 0.05 with the ROC should be greater than 0.05 e power minus. What is the correct answer? Option C. Option C is the correct answer. That's all. Now see how easy this question is. இதல டஃப்னஸ் இருக்கா? Nothing is there. நான் எதுவுமே பண்ணல, ஜஸ்ட் கொடுத்த டேட்டாவை அப்படியே சிஸ்டம் வழியா பாஸ் பண்ணி அவுட்புட் எடுக்கணும். Did I did any big derivation? No, right? So that is how your questions are being framed. Okay, let us see next question. Next questionல ROC தான் கேட்டிருக்காங்க. அதுக்கு அடுத்தது இந்த மாடல் நம்ம ஏற்கனவே பார்த்தாச்சு. Same model. Let's see if I find any new model. No. These things you can solve. Okay, I think remaining question you can solve because whichever the model that we saw earlier, same model will be there. You can try it by yourself, right? Discuss in the group, right? I have seen nowadays you people are not doing the discussions in the group. Unless your exam is getting close now, if you find any doubts, immediately you have to post it in the group, and whoever the people group la irukavanga ungalku answer theriyadhu appadina you have to support them. So this controversy neenga argue pananum, idu eppadi ipdi varudha, that things will going to help you to grow up, right? Okay, from this weekend onwards I will release the results. That will, you have to compete with yourself first, then only you become the master, right, in your field, right? Fine. Z transformation is completely over. Next we are going to start what I can say sampling theorem. With that our signals system is completely over. Listen, there are some other topics like I have seen it, filters. That is only one topic, that is filter. After completing the analog electronics, I will take that chapter. This is the first time I have seen that syllabus, right? Anyway, in that area I have not seen the questions, right? Anyway, we have to touching that area is our responsibility, but not now, right? In analog electronics some basic filters are there. We will complete all those things. After completing the filters I will take that one. That's very small topic only. We are not going to deeply analyze those things, right? Just we will touch that portion. Anyway, the major portion 99% as well as in your exam point of view, all these portion have been covered fully with the sampling theorem. Tomorrow I will complete that one also. Then we will start the next subject. Okay, if you have any other doubts, please you can ask in the group, right? So let us wind up. Thank you all.